more interactive. And the connectivity. As a digital highway. So if we build the highway, if we build the road, that's good, it's great. It takes us from A to B. But it's not enough, because for people to use the road, people need infrastructure, right? We want street lights, we want road signs, we want safety measures, we want bridges, we want services alongside of the road. So providing connectivity is fantastic, and it's the foundation and the basis. Without that, we will not be able to communicate today. But we need something else on top of connectivity. We need infrastructure and services. And here you can see a very schematic map of UIIP Connect project countries, and Belarus is here. And the very brief list of services and that are available through Belarusian Research and Education Network, which is represented by the United Institute on Informatics Problems of the National Academy of Science of Belarus. So as an end user, we may not be aware of the services, and it's a good sign, because if they're provided seamlessly, we just use them without thinking what they are. Yeah. For example, if I am a scientist or researcher in University of Cambridge, and I have my collaborator somewhere in the University of Catalonia, we work together, we communicate online, we exchange data online, we can access resources in each other's institutions. And for this, I log in as normal in my computer through my institution's network. And here I am. I can talk to my colleague. We can see at the library. We can use the same online resources and databases. It is because both institutions use the services of EduGAIN and EduRoam. Yeah, it provides that seamless and safe federated access management and access to online resources for researchers. So GÉANT does that, yeah, and that service is available for to be used on the National Research and Education Network in Belarus. That's why I mention it here. So that's another connection, right? So we built the roads, we provided connectivity, we provided infrastructure and services on top of it. So we now have users that actually using our services and our digital highways. So what GÉANT does, but scientific communities are very good at building their own networks. But the world is so diverse these days, and these communities are so diverse that sometimes there's just too much information, and it's difficult to find the right people, like-minded people. So GÉANT has the function of working with research and education communities in different parts of the world with the aim of enabling collaboration between scientists, researchers, and educators. And this is a short list of scientific groups that GÉANT liaises with. Of course, the list is much longer, as Chris probably will tell you, but this is just to give you an overview of what is represented. Yeah, the groups of scientists that GÉANT works together with the aim of enable collaboration, bring the scientists together, and support them. Yeah, and what they do. We do that working with research community in different ways through a number of means, and some of them are listed here. Yeah, like community conference, and Belarus took part in the conference this year. There are special interest groups in task force. The one particular of interest for UIIP Connect partners is the eHealth group, and they take part in the work of that group. So also, we have a dedicated sort of service within GÉANT that aims to be like a dedicated single point of contact for each National Research and Education Network. So when Alexei informed us of the upcoming conference, we were very sort of interested and to see how we can help, and through activities that Chris is absolutely fantastic in providing, just to notify some of our contacts out there to say, hi, have you heard of this conference? I know you work in the same area, will be of interest to you. And this is how the GÉANT session this morning happened. Yeah, so that's the connection. That's what GÉANT is about, and that's why we're here for this morning. And just very briefly to say that GÉANT is really, yes, provides connectivity, but it's more than that. Yeah, the benefits delivered by connectivity are only realized if there is a network of people, and that is what GÉANT does, bringing the people together. So on that note, I would like to finish. Thank you so much for your attention, and wish you, I was going to say wish you a great conference. You already have had a great conference and continue to have it. So just, yeah, enjoy and have a great time. And I thank you so much.
Thank you very much, Irina. And it's a great introduction there to who GÉANT is, what we do, and also the benefits that are applicable to the likes of national research and education networks across Europe by working and collaborating together. As you said, GÉANT is building the digital infrastructure and services to support the next generation of research. And I think AI is one of those areas that's key to the next generation of research that will impact all of us around the world. I'm going to move over and introduce our next speaker. This is Hirac, who is from Armenia. Hirac Astarian, and I apologize if I pronounce your name incorrectly. He studied mathematics and graduated from Yerevan State University in 1998. In 2001, he received his PhD from the Institute of Informatics and Automated Problems of NASRA in France. And in 2020, a habitation degree from the National Polytechnic Institute of Toulouse. His research experience is related to, well, the topics of e-infrastructure and science research and scientific computations. He's authored more than 70 articles in the revised journals and proceedings, and he's the director and the head of the Center for Scientific Computing at the Institute of Informatics and Automation Problems at the National Academy of Science in the Republic of Armenia. So I'd like to hand over the floor now to Hirac to talk about your presentation. Thank you very much.
Thank you for the introduction. Good morning, everybody. Thank you very much for the invitation, which is excellent opportunity for me to present the Armenian Data Group as a joint Swiss-Armenian initiative on deploying and implementing a national scale Earth observation data group. As Irina mentioned, in the GÉANT community, one of the key research community, this is the Earth observations and environmental community. The Armenian Data Group is a joint effort of the University of Geneva and 2 Armenian research institutions of the National Academy of Sciences, namely the Institute for Informatics and Automation Problems and the Center for Ecological Noosphere Studies. The outline of my presentation consists of 6 points. First, I will introduce the topic's background. Then I will present the Armenian Data Group, including the platform and functionalities. Finally, I will show the ecosystem around the data group that we suggest, which includes the algorithms, methods, and also some services, which we already deployed and provided to different user communities in order to get benefits from the Earth observation datasets. Let me present a short introduction on the challenges that we face, why it is so important for us. Environmental problems become an increasing global concern and continuously put stress on natural resources, and global challenges with ecological dimensions such as freshwater, air quality, deforestation, land management, or urbanization require improved and updated information, which needs the dynamic nature of environmental conditions. Earth observation data, I mean the satellite and in-situ data, provide robust monitoring mechanisms for above-mentioned environmental problems because of their geospatial consistency, accessibility, and global coverage. Earth observations are critical, especially for developing countries like Armenia, having limited in-situ observation and also digital modeling data outputs. So that's why this is especially critical for the developing countries by getting some additional data sets to monitor the environmental challenges, or to improve the decision-making for different societal challenges.
Hirac?
Say yes?
Sorry to interrupt. I believe you're on presenter mode. I think you need to switch the presentation type around.
Okay.
We can see your notes, sorry.
Okay. Now?
Let's see.
Sorry.
It's okay.
Now it's okay?
Yes, perfect. Sorry to interrupt.
Okay. So as I mentioned, the Earth observation datasets are especially critical for the developing countries like Armenia, because we have limited in-situ data or digital devices, which is critical in order to have proper monitoring of environmental and different societal challenges. So that's why we are quite interested in order to implement this kind of additional and high quality data sets to improve the monitoring and also to improve the decision making for different challenges in Armenia, but also beyond in the region. So the key benefits of using Earth observation datasets are quite diverse. And for instance, the resolution is quite important for us. By getting the Earth observation data, we can provide to the user communities the satellite images with up to 10 meters of resolution, which is quite nice with the free of charge by different satellites like European Sentinel or US Landsat satellites. And also we can get some temporary resolution to get these images in a continuous way. For instance, in case of the Sentinel, it's 5 days, or in case of the Landsat, it's 16 days. And also the time series is quite important, because if we are doing, let's say, research, we need to have a data set for a long period of time. And we face such challenges in Armenia. For instance, we wanted to do some monitoring or management of the water resources. Then in order to evaluate different digital models, we couldn't get a proper and long continuous data sets for the evaluation of different digital models. So that's why this time series component is quite critical for the monitoring of environmental challenges. And also the scale and availability. We can move from the local scale by using only the local devices or the data received from the local sensors to the regional or global challenges, because these satellite images provide the data in a global scale. But also we may have the data not only up to now, but also for the future, for the next 2 decades and farther on. And also, this is quite important, it's an additional source of information, because we started to deploy different methods, algorithms, and services by using not only the Earth observation datasets, but also datasets which are coming from the observational stations, but also the outputs of different digital models. And it is also very, very nice that by one image we can get several information, because we receive these multispectral images from the different satellites, which is quite important if you want to do some complex simulations to calculate some mix of different indices for a specific challenge. So in order to be able to do in a proper way the Earth observations data groups, lowering barriers in Earth observation data by delivering applications and products harnessing satellite Earth observation data. So that's why it's somehow a bridge between the Earth observation data and the services that we can put in a place in order to get this kind of Earth observational data sets in an easy way, and also by using some different APIs, libraries, and methods, not only to extract, but also to process this kind of Earth observational data sets. So now let me to present the Armenian data group, which we started 3 years ago. And we are one of the pioneers worldwide in order to deploy such a centralized data group for Armenia. But also we use these the data sets of this of the Armenian data group, not only for addressing different challenges in Armenia, but also for cooperation with our colleagues from Europe and United States in order to validate their models by using our datasets, or to validate our models to using their datasets. So that's why it's also due for an international cooperation to bring together not only the infrastructures, but also competencies and also the datasets. So that's why we started this initiative a few years ago, and we continue, we extend our opportunities in order to provide different services to not only to the scientific community in Armenia, but also the stakeholders and decision makers. So actually, the partners that involve in the establishment of the Armenian data goods includes the Institute for Informatics and Automation Problems of the National Academy of Sciences, which is the leading institute in Armenia in the domain of computer science and informatics, and which also operates the national complex infrastructures, which consist of data computing and networking infrastructures. And in this collaboration, we provide support and expertise in high-performance computing and geocomputing by using and by suggesting different methods and algorithms in AI and parallel computing. And our partner, this is the Center for Ecological Noosphere Studies, which was founded in 1989 by the decision of the government in order to have a centralized institution which will involve in the studies of ecological and noosphere topics. And they are doing multidisciplinary investigations in remote environmental observation and monitoring. So actually, the Armenian Data Group, it is funded not only by these two institutions, but also we could receive different projects which was funded by the University of Geneva, but also Swiss National Science Foundation, in order to create some international collaboration. And the University of Geneva was one of the pioneers in this field worldwide. And so that's why we are very thankful to have this collaboration, especially with them. And the Armenian Data Group, this wider international consortium, allows us to use these Earth observational data sets to address different environmental challenges, and also to change the mind of the decision makers that this kind of data sets can be a good source for their decision making. And also we started to think about the sustainable development goals of the UN up to 2030, and in order to synchronize somehow some activities of the Armenian Data Group with these SDG goals of the UN. And also this is, as I mentioned, this is a sufficient alternative way in order to provide some additional data sets to the decision makers and the scientists. And the infrastructure that we used, this is the infrastructure which we have in Armenia, which is used by the Armenian Data Group, and which is one of the pillar applications for our infrastructure. And we have computational infrastructure, which consists of cloud, HPC, grid computing, diverse infrastructure, some storage resources, data processing resources, some algorithms, and also software packages, which we are using for different services and geocomputational processes. So actually the capacities that we have in Armenia, this is the networking facilities which provide networking to about 65 research organizations, including our partners that they are using the data sets of the Armenian Data Group. And also, thanks to the UIIP Connect project, we have a direct connectivity to the GÉANT with currently 2 gigabit per second, some storage capacities, and some computing capacities. And at the end of December, we will have a new supercomputing center in Armenia, which will consist of about 12,000 CPU cores, which will improve our capacities a lot. The Armenian Data Group platform actually consists of these 5 different layers. So the first layer, this is the observational satellite and digital model layer. So which means the first layer, this is the data source layer in order to store, to process, or to visualize. And here we use actually 3 different types of data sets. So as I said, satellite, observational, which we receive from the Ministry of Environmental Protection, and also some outputs of digital models, like the model of weather research and forecast, or the model of POSMO. And here the tricky moment is how we can process, how we can extract the meaning from these different data sets. So that's why in the next stage we are using some computational resources, mainly cloud computing and high performance computing, in order to extract, to do some processing of these different data sets. And then in order to improve the process, of course, we are using some machine learning and parallel computing algorithms or methods. Machine learning in order to improve the decision making, or to increase, to do some evaluation, increase the performance somehow. And parallel computing we are using especially to decrease the simulation time of complex scientific workflows. And of course, we are using the Armenian data group in order to extract the data from these different sources, and also to upload the results of different services. And of course, we are providing at the end some services like to calculate different indices from different satellites and from different data sources. So this is the key architecture of the Armenian data group, which consists of 5 layers, as I mentioned, including data, computing, methods, frameworks, and services. The data which is available now, we are using a lot the Landsat 8 satellite and also the Sentinel-2. And just recently, we started also to upload the Sentinel-5, which is quite critical, especially to do some calculations of air pollution applications or challenges. So what is our approach? Our approach is the data group, which is just a platform to do some studies. And here our ecosystem consists of the data group in a bottom layer, and 3 different components that we are putting on the top of the data group as a platform. So these are the algorithms, these are the services that we are providing to different user communities, and these are the methods that we are using or studying by using these the Earth observation data groups. And I will highlight just a few typical algorithms and methods or services that we have already developed and suggested to our user communities. So first of all, the algorithms, as I mentioned, in terms of the algorithms, we are quite interested to provide parallel algorithms, because until now, this community, they are mainly rely on sequential algorithms, or in a good case, in the multi-core algorithms, to using just the capacities of the multi-core machines. But now we started to implement different algorithms in order to increase the simulation time of complex workflows of satellite image processing. And for instance, on the top of this algorithm, which we deployed many years ago, now we work on the Python parallelization algorithms, and we submitted a new article on this, which allows us to do parallelization of already available libraries by adding just a few lines of codes on already available codes of the user communities. Another approach is the methods that we are suggesting or developing for our communities. And one of the methods, this is the weather forecast, for the weather forecast. And because this is quite important especially for Armenia, because the relief of Armenia is quite complex. Though the country is small, but the relief is quite complex with different zones. So that's why it's quite challenging for Armenia to improve the weather forecasting and also, let's say, air pollution monitoring and something like this. And now we are interested to deploy some methods, and we focused in the first stage to the Ararat Valley, because this is the main agricultural area for Armenia. So that's why it's quite important to suggest some methods, which is quite important also for the agriculture. And here you can see that our methodology, which we suggest to our user community, consists of 5 modules. So pre-processing model, where we put all the input data to different deep learning and machine learning models by providing different data sets like hourly air pressure, relative humidity, wind speed, dew point, temperature, and many things. Then the next model of our methodology, this is the analyzer model. And here we use split window algorithm in order to retrieve the land surface temperature, which is a quite good source in order to do some evaluation with the temperature from which we receive from the different sensors. And then this kind of huge complex of data sets we are providing to different deep learning and machine learning models in order to evaluate and train. And here we used different, we examined different well-known machine learning models like Prophet for this time series analysis, especially which are good for this time series analysis. For instance, the Prophet model method, which is suggested by Facebook, or Sarima, which is quite well-known model. And then by having different analyses, we suggest our model by building a neural network which receive this huge amount of data sets, and in order to increase the quality of the prediction of the air temperature, especially for the Ararat Valley. And here you can see the result in comparison of our model with other well-known models. And now we are going further in order to combine these algorithms with the methods to provide some user-friendly services to the ministry or to the community, because otherwise they will need to do different processes, different complex analysis, which is not so easy. Concerning to the services, we are mainly focused on 2 services until up to now. This is air pollution and shoreline delineation. And we suggest these two services. For instance, in case of the shoreline delineation, we suggest a service which consists of data validation, data processing, data extraction, and data repository levels. And here we combine, as I mentioned, we don't use only the satellite images. We want to compare these Earth observation data with other data sets. And in this service, we are using some data which we receive from UAVs, from drones, in order to increase the shoreline delineation and also the changes of the shoreline delineation, which is quite critical for Armenia because of the deforestation processes, especially which is going in a very bad shape because of the climate change. So that's why we develop this kind of services, because there is some demand from the stakeholders. And we implemented this service just for one part of the Lake Sevan in order to understand how will we identify the shoreline. And here you can see that in the service we are using many bands or many indices, and also we are doing several calculations from different methods, let's say band ratio methods or different delineation models. The service is accessible from the Jupyter Notebook, which access the data sets from the Earth observation data pools, and then to do some complex processes in order to provide or to delineate the water from the water indices. And then it's coming the data processing in order to extract the data. And here we are using K-means clustering method in order to do the data processing, which we receive from different methods, as you can see here, and then blurring the images by Gaussian functions. And here you can see some results which are quite interesting. So actually in this service, we are using different well-known algorithms, and then we are providing the accuracy of these different methods to the research communities and also the stakeholders. And then in a visible way, they can judge or they can decide what to do, because they receive images, also they receive some tables where it is mentioned the accuracy of different methods. And here again, so it's a complex method which consists of several stages or different algorithms. It's a mix of different algorithms. And another interesting story, this is the air pollution monitoring. And we started to do for the nitrogen dioxide over the territory of Armenia by using the Sentinel-5P Troponin satellite. And it is a new satellite, and there are no lot of research on this respect, because the satellite was started to provide the data since 2018. But the satellite provides very interesting data sets, let's say 2.5 PM or 10 PM, which is quite influential to the health of the pupil. And here our methodology, it consists of different modules. Again, this is the data collection model, data preparation model, computing infrastructure model. And here we deployed an interesting algorithm based on the Dask parallel Python library by using high-performance computational resources. And then the data processing, and then data visualization. So again, it's a complex solution, and the user, they just indicate the time period and the region that they are interested to study, and then all the rest is done by the service by calling these different models and different libraries. And then one model, or the output of the one model, it goes to the input of the next model. Here you can see the evaluation, interesting pictures related to Armenia. And we evaluate NO2 for each stations. And here, maybe it's not so much visible, but also per each region of Armenia. Because by having this evaluation, then we went further. Because if the evaluation results are good, then we put some additional artificial stations in Armenia in order to provide these artificial stations to the input of the digital models in order to increase the accuracy of the monitoring and forecast of air pollution and the weather. And I would like also to mention that just recently we received a joint project, Armenian-Belarusian project, on this around this topic, which we entitled Remote Sensing Data Processing Methods Using Neural Networks and Deep Learning to Predict Changes in Weather Phenomena. And we would be happy to start a new collaboration with our colleagues from Belarus. Thank you so much. If it was quite long, I'm sorry.
No.
I would be happy to answer to your questions if you have any.
Iraq, you were perfectly on time. Thank you very much. It was a really interesting presentation, especially on the idea of merging infrastructure and services to provide the platform for AI. Just a quick question: how much of a challenge is pre-processing the data from the likes of Landsat and Copernicus in order to ingest it into the data cube, and to an extent, how much work is required for AI to utilize the data cube for the algorithms?
Actually, it is done currently automatically because we developed some scripts, and we run the scripts during the nighttime in order to get these data sets, to ingest these data sets, and then to upload to the data cube. So that's why the time for this is not so much important for us, because it is going on the nighttime. But for us, it's quite important the processing of this data in order to use this data for different challenges.
That's great. Thanks very much, Iraq. I really liked as well that on the shoreline delineation slide, it looks like you've picked up the bathymetry of the local shoreline as well for the lake. So that's quite exciting too.
Yes, and it's quite important also, for instance, for the climate change, for instance, the deforestation, in order to understand the dynamics of the shoreline of your water resources.
Perfect. Thank you very much, Iraq, and great presentation. Now, moving on to our next speaker, we have Marek Justina, who's a data scientist at Poznan Supercomputing and Networking Center, or PSNC, that's based in Poland. His specialization is in developing deep learning models for image processing, but recently he's also been involved in delivering such models to production, both in Europe and for commercial projects on AI. His presentation is titled Image Processing or Machine Learning, What is Better for the Quality Control of Electronic Components. Marek, over to you.
Hi, Chris. Hello, everyone. Thank you for this introduction. Yeah, so now let me share my screen. So you should be able to see it. Okay.
Yes, we see it perfectly. Thank you.
Okay, so as Chris said, the presentation is image processing or machine learning, and a dilemma in the quality control of electronic components. And my name is Marek Justyna. As Chris already said, I'm data scientist at data science researcher at Poznań Supercomputing and Networking Center, and I mostly engage in developing AI algorithm and making the AI researches. And I have also high experience in implementing neural networks, but recently I've also engaged in deploying such models or such approaches to production. And today I would like to follow the agenda. So at first I would like to make a brief introduction to a problem we are trying to solve in PSNC. So the introduction to a problem about the quality control of the electrical components. After that, I would like to show you very quickly the pre-processing we are doing when solving these problems. And after that, I would like to skip to methods. So we have a variety of methods. We have those both methods based on image processing and also methods based on neural networks. So in this section, I would like to present you what methods we have developed and what are the advantages and limitations of each of these methods. And after that, we can make short summary and discussion. So in the introduction, this work we are doing right now is a part of Shop4CF project. So Shop4CF stands for Smart Human-Oriented Platform for Connected Factories. And in this project, the goal is to develop a variety of different components which could be placed in something like marketplace or market store, where the potential other clients or other factories, for example, could browse for different components and choose or select the appropriate ones to their use cases. And to develop this component, we have cooperation with Bosch, where we want to develop a pilot of our component. And our component we are developing is called Visual Quality Check. In short, it's VQC. Yeah, and as I said before, the goal of this component is to create a tool for visual quality inspections, which could be easily adapted to new use cases. So yeah, to fit these to this market store, so other factories could adapt it to their use cases. And the goal of this pilot project with Bosch is to detect missing components on assembled PCBs. Because this Bosch branch is placed, this is a factory placed in Spain. And what they are doing, they are simply assembling the components like on PCBs, like for example resistors or some other typical PCB components. So what we have, they have as an input, they have let's say this raw PCB, and the operator, so the human worker, the goal of the human worker is to mount these components on the PCB. And as you can see, there might be several different components, and there also might be several different kinds of PCB, and each kind of PCB might include different ones. So the goal is to make a detector which could tell us if the operator misses or does not assemble some of the components, right? And in our assumption, we have, I would say, quite little data. So this means that we only have a template. So the template means that we can get an image of the correctly assembled PCB, and the other can be test samples. So this can be any sample. So this can be completely empty, but this also can be any test sample the operator puts to our detector. So, as I said, known limitations are as follows. So the data set is quite small, and there is also high diversity of PCBs and components. And what is more, the annotations are not available. So we only know the template, as I said before, and we know that this template is a correctly assembled PCB. And we can get few PCBs without any component or with missing components for tests. And actually, that's all we can get. So to use it, we have also found other data sets, because from Bosch we could not receive any more data. So we have only 3 samples, which was not sufficient for us for the tests. And what's more, so we also used other data sets. Here is linked one of them. And what is more, the samples from Bosch were, let's say, quite noisy. So the other data sets could help us also to see the way that the proper data sets should be collected. So here you can see the image from this publication, this paper, how this team has collected the data sets we were operating on. So we can see that they have, let's say, the camera, they have very stable stand, and they have additional light source. So this kind of paper, this paper also helped us to make recommendations for Bosch on how to build such inspection station, right? So they can use the very similar approach. Okay, so now we can skip 2 methods. So how to solve this problem? At first, we have to start with the pre-processing. And in this section, I would say the most important thing is the alignment of the samples. So basically, we have, let's say, the image like this one here, original, marked as original. Let's say this is our template. And when the operator puts the template image, or the test image, for example, like it was here. So when the operator puts it under the camera, this is possible, but each time this might be slightly rotated. Oh, sorry, something went wrong. Oh my gosh. Oh my gosh, sorry. My Microsoft just died.
It's okay, Marek, don't worry.
Okay, we are back. I believe you can see the screen or not?
Not yet.
Perhaps you stop sharing the screen.
Yeah. Oh, there we go. Perfect.
Yeah.
It's
Okay.
back on now.
Okay, I'm very, very sorry for that.
Sorry.
So the goal of this pre-processing is to make as perfect alignment as we can do. So we have, let's say, the input image from the operator might be slightly rotated. So we want to align these 2 images, or align this test sample on our original as perfect as possible. So in order to do it, we use the ORB method, and these ORB methods can find the features or the descriptor of each image. So when we can find the descriptor on our template, and we can find mostly the same descriptors or mostly the same features on our rotated image. So when we find the sufficient number of these features, we can try to align most of them one by one. So we can, after that, when we have these features aligned, like in this image here, so we can see the connections between those features. We can use the method also from OpenCV. It's warp perspective, and this warp perspective function can allow us to reach the final result, which is warped image. And actually, when we find sufficient number of features, for example, 100 or 150, we can make a very good alignment. And this alignment can, I would say, facilitate the further processing. So it simplifies the problem, right? So we don't have to worry about the rotation. So the first method is very simple. The first method is image subtraction. So basically this means that we have a template image and we have our test sample, which is after pre-processing. So this is well aligned to our template. So after that, we can make subtraction. So let's say make the template image minus our test image. And the difference between these two images might indicate the missing components or the problems we want to detect. As you can see, even though we have very good alignment, it's almost pixel perfect alignment, but it's actually, unfortunately, almost. It's not very perfect, but we can still see that there are some points which can indicate which are much brighter than the rest. So after performing some morphology operations, we can simply get a mask which indicates the main differences or the biggest differences between these two images. So this method has few advantages. So this is quite fast. So it doesn't require any dedicated hardware. So when we have, let's say, on the backend, on the edge, when we have a very small and not very powerful computer, we can still quite easily use it. What's more, this is also quite easy to implement. And what is also quite important for us is easy in interpretation, because after the discussion with Bosch, we found out that the interpretation of the results is also quite important for them. So they want to know why the method produced such results, if there are, for example, any false positives or something like this. And the other advantage is that no annotations are required. So we can use a template image, and after that we can just test it with our test sample, and we don't need to train it, or we don't need any annotations. However, this method also has some limitations. So as I said at the beginning, it requires perfect alignment, and the better the alignment, the better results. Perfectly, it should be, let's say, pixel perfect alignment. But as you can see, this is almost impossible to reach out. So that's why we need the post processing. So that's the other limitation. So after this operation, we need to make some morphology operations, for example, erosion or something else, in order to remove the noise which comes from the method. And the other limitation is that the images should be in high quality, so should be captured in the same conditions, especially in the same lighting conditions, so that we don't have any brighter regions or shadows or something like this, because this also has quite big influence on the images and on the results. The other method is template matching. Template matching is also implemented in OpenCV. And yeah, basically the template matching works as follows. So this is our template image, and we want to find this image or to fit this template in our bigger image. So this is just a visualization from the tutorial for OpenCV to give you more intuition about how this basically works. And we can observe bright points here means that in this point is very good alignment. The rest of the points, so the brighter the point, the better alignment or better fitness of the template. So we can try to use it also in our use case where we want to detect some components. So what we can do is, for example, is to make something like a grid on our PCB, and the size of the grid or the size of the square, of course, may vary. So we can try to with different sizes to get the best results for given use case. And basically, this should work as follows. So we can take any square, for example, let's say this one, and we may want to find this square somewhere in our PCB. And if we find it with very good fitness, with very good similarity, then it means that this region is not damaged or is exactly the same as in templates. So, but if we try to find any other regions and we cannot fit in very good way, then this may mean that something is wrong. So here are the basic results. So as I said before, when we are matching templates to correct parts of the image, then we can get very good fitness, which is almost is one or almost very close to one, let's say 0.999. But we can also try to match templates to defected parts, and after that we can see that the similarity is lower, especially in these cases. We can also see the disadvantage or the limitation of this method, or maybe of this grid approach, that if the defect, like for example here, is very close on the edge, this similarity is still very big. But we can also try to optimize this, for example, to not make, let's say, a grid, but to look for similarities in some region, not grid per square. So the advantages of these methods are also that it's quite easy in interpretation. This can be still fast when it's optimized. So we can also try to make some kind of optimization, as I said before. So for example, not to try to find each square in the whole PCB, but each template image, we know that this should be in the same, more or less the same region. So we can only limit to this region. It also does not require dedicated hardware. And like in image subtraction, it also does not require annotations. However, as you can see, the similarities with defects are high, and yeah, we did it on many different cases. So because here are problems with soldering. So this is not we have missing holes. But we can also we have also tested this this approach on PCBs where we have much bigger defects. So, for example, actually really missing components, and the similarity is lower than here, but still very high. So, for example, about 80 or 85%. So this is the main limitation. But this might be sometimes confusing or difficult with thresholding. And the other limitation is that the alignments of these images still should be very good. It does not have to be so perfect like in image subtraction, but still the alignment has very big influence. on the results we are getting. So these two methods were based on image processing. And now I would like to show you a method based on neural networks. So in this approach, we use triplet loss. And triplet loss was primarily designed for face recognition. It was designed by Google for face recognition. And the idea behind this algorithm is as follows. So we have neural network which we want to train to distinguish between the samples. So we have anchor sample. So this might be anchor image. We have also positive image, and anchor, in our assumption, anchor and positive image are very similar. So for example, anchor may be some part of PCB, and positive is the same part, let's say, of the same PCB, but for example, in different lighting, but generally they are the same. And negative is something completely different. So we want our neural network to distinguish between these samples. So when we have distances between these samples, after training, we want to our positive sample to be as close as anchor to as possible, and negative sample to be as far as possible. And basically, we can still try to use very similar approach as in template matching. So when creating these anchor and positive and negative samples, we can use something like a grid where each square is the input. So for example, this square might be the anchor. The same square in different lighting conditions might be the positive sample, but any other, for example, this or any other square might be the negative sample. And we want our neural network to maximize the distance between these three, between negative and positive and anchor samples. So here are the basic, here are the results. So the first image on the left is anchor. The middle image is positive sample, which is primarily almost the same as anchor. And the last one is the negative anchor, is the negative sample. In this case, we also used other data sets just for this test, where we had labeled components, so that we could make artificial samples where we could copy and paste the components in the image. So in positive and positive sample and anchor, we could paste some components, and the negative sample did not have it. But generally, the region was exactly the same. And what we can see that the similarity between anchor and positive is 91, almost 91%, while the distance between anchor and negative, the similarity between negative and positive and anchor is only 31%. And what is also important, as I said before, this anchor and positive, the difference between anchor and positive is the lighting conditions. So one of these images always a bit brighter. This is maybe not very visible on this image, but yeah, generally this was our approach when we were training this. Here are also some examples. So again, we have anchor, positive, and negative, and we can see the similarity about 83% between anchor and positive, and only 62% between anchor and negative. In this case, we have the image, the actual image, the real image from what we have received from Bosch. So from Bosch, as I said, we have received 3 images. 2 of them were correct, and 1 of them was with missing component. And we tested this in the following way. So this was the first correct image. This is the same region in the second correct image. And this is the same, let's say exactly the same region, but in the PCB with no components. So we can still see the difference in similarities. So the similarity between anchor and positive is 93%, and the similarity between anchor and negative is only 65%. So we can still distinguish these samples. Yeah, and in this slide, I would like to tell a few things about the explainability, because as you probably know, the explainability of neural networks might be sometimes problematic and might be sometimes confusing. So, and this may be especially difficult in neural networks like for example triplet loss, because we don't have, like, for example, classification where we could quite easily backpropagate the gradient and see at what parts of the image the neural network pays attention. So what we decided to do is to visualize the last convolutional layer of the neural networks. So when we have such images where between anchor and positive is 87% similarity and anchor negative is 44%, we can observe the reaction of neural networks. So what does the neural network actually pays attention on? And we can see that in these cases, it pays quite big attention to these components which were, let's say, artificially added, while in this region, in this sample, the interest is, let's say, distracted, so it does not focus on any specific region of the image. So the advantages of triplet loss are as follows. So this can be trained in unsupervised manner, and it does not require pixel perfect alignment of samples. So this might be a bit more rotated. So we can still try to we can still train it correctly, even if the samples are not perfectly aligned. However, this still has some limitations. So as you can see, the interpretability of the results still might be confusing. So even though we can see that the neural networks tries to focus on some regions, this still might not be sufficient for the operator, and it might be quite hard to understand. And what's more, as we are using neural networks, this is much more computationally demanding. So this may require dedicated hardware to run neural networks on the edge. So, for example, NVIDIA Jetson or Intel MoviDeus. And the effectiveness of this approach is also quite limited, because when the changes are very small, then this might be not enough to detect these errors. Yeah, and the alternative we are also thinking of could be variational autoencoder, which primarily we could use in quite similar ways. So also use the latent space and measure distance between the samples. I also would like to tell you a few things about other alternatives. So we were also considering other neural networks, like, for example, YOLO. So this is a network you only look once for object detection. And the advantages of this approach is that this might be quite accurate and does not require perfect alignment. So we can try also to run it on almost any sample or any image. And this could be also less sensitive on lighting conditions. So this we would not have to require so specific test stand where the light source is very, very strong and very programmatic. However, this has few limitations. So this requires high quality data sets with labeled components and sufficient amount of training samples. And actually, this is the main reason we are trying to avoid this approach, because most of partners are rather subject. From my experience, most of partners is not very willing to generate data sets which consists of thousands of images and labeled objects, right? And this also requires dedicated hardware. So I would like to go to the summary. So the main limitation of this pilot is the amount of data. So as I said before, we can get very few data, and these data are usually not labeled or very poorly labeled. The other recommendation, maybe what I have heard, is not to use neural networks if it's not necessary. So image processing methods can still produce satisfactory results, especially when the elements like for example PCB are very similar to each other. Yeah, as I said, in some cases the neural networks might be obligatory, but maybe not in detecting missing components. This might be more useful, for example, when you want to detect something like crack or scratches on some kind of surface, when the definition of the defects is very, very different. Yeah, and maybe the YOLO detection maybe also use it when we want very quickly detect objects on the specified object, and also or to classify it when it can be in any position. And the last point should be that the better quality of the input, the better the results. And in our cases, all presented methods produce satisfactory results when they are properly adapted. So this means that in our tests, or in these data sets, we were able to find all defects when the methods were properly adapted. So when we have configured all the parameters and so on. So thank you very much for your attention. And if you have any questions, I will be happy to answer.
Thank you very much, Marek. That was a really interesting presentation. So I just made a few notes as well, and I like the way that the idea behind the entire presentation was the use of AI to identify production issues during PCB assembly for Bosch. One thing that sprung to mind though was the use of OpenCV, and that the idea of using open source software tools in order to complement the research or the algorithms that you're producing. Was the walk perspective function part of the OpenCV toolkit?
Yes, it is a part of OpenCV, yes.
And how essential would you say are open source functions for your field of AI?
Sorry, could you repeat?
How essential are open source functions and tools for the research that you do in AI?
I would say this is very, very essential. So actually, in my opinion, this is the basic. So if we have some of tools are very, very good, but if they require license, in some cases this might generate some problems. So the usefulness, it might be limited. So this also increases the cost of the whole project, right? So in my approach, I usually try to use open source methods and tools, and yeah, usually this is very good.
I mean, for you, where would you find these open source AI functions?
To be honest, as most of programmers, I usually use Stack Overflow, because at the beginning we also had, for example, problems with these feature alignment methods I told you at the beginning.
Yeah.
We have found one method, but after some research, we found out that the algorithm, I'm sorry, I don't remember the name of the algorithm, but this algorithm we found at the very beginning, it was commercial. And actually, in order to use it commercially, we have to pay the license. So we wanted to find any alternative, and thus, after some research, we found out that OpenCV has also alternative, which works slightly different, but for our purposes, this is completely fine because it does what we expect, and this is open source. So yeah, this is always not very easy, but after doing some research in different forums, like for example Stack Overflow, we are able to find the results.
Great. And the other bit that kind of struck me as well was the fact that, as you said, the alignment is crucial to the algorithm. But it's still, for me, going back to the actual core problem, which is working with Bosch. Do you think that in an industrial setting, it would require adaptation of production lines in order to implement the proper type of testing station? Do you think that's the answer, or do you think that AI techniques can improve to a point where the testing station doesn't have to have stringent tooling in order to align and light the PCBs correctly?
Well, to be honest, in my opinion, we can always try to use neural networks, and of course, this always can make sense. But in my experience, sometimes this might be simply too difficult. So we just harden our life because, yeah, as I said about this, for example, these lighting conditions, this actually has very, 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 very crucial impact on the images and on the results. Because when we have, for example, some regions which are too bright, so overexposed, or some other regions which are under the shadow, and every time we make a photo, the image, the outcome image is different, then this may cause some other problems, and we can put a lot of efforts in order to make a neural network which could handle this and still produce satisfactory results. And on the other hand, we can just use, and for example, I don't know, buy few lighting source, for example, $100, and simply solve this problem and use a simpler method and reach the same results. So yeah, in our approach, in my opinion, this is the most important thing. Is the most important fact is to get the best results, but the methods is not always important. So if it's not necessary, of course, use neural networks. But if you can try to do it in a simpler way, try to make it simpler, because it's also easier for you to maintain. So yeah, that's my opinion.
Great. Well, thanks very much, Mark. That was really interesting. And now we're going to move on slightly to our next speaker. This is a talk by Peter Bos. So Peter graduated with a bachelor's degree in IT from Hansa University in Groningen in the Netherlands in 2014. Initially, he worked as a SRE at a Dutch internet service provider. And in 2016, he graduated from the University of Amsterdam with a master's in systems and network engineering with a speciality in advanced networks. From 2016 onwards, he's been involved in automation and orchestration efforts at SURF, the National Research and Education Network in the Netherlands, specifically in their networking department. And together with a small team of architects and software engineers, he works on the orchestration platform, which delivers services seamlessly across the Netherlands and other parts of Europe. Peter's talk is titled SURFnet 8, Evolving from Device Automation to Service Orchestration. And so, Peter, the floor is yours.
Thanks, Chris. I'm sorry. I'm feeling sorry for you having to pronounce the Dutch names of cities. So I hope it wasn't too difficult.
No, don't worry. Actually, I live in the Netherlands. I live in Utrecht, so
right.
I should learn how to pronounce them properly.
Yeah, great. Okay, well, I'll start sharing my screen and then we can move on. So, all right, thank you very much, everyone, for inviting me to give a talk. It will be a little bit less focused on AI and signals, but I will try and explain a little bit how we do see a use case in the future of using AI and machine learning to manipulate our network. Probably many of you might recognize this entry screen a long time ago in an NREN far, far away. I'm going to tell a little bit of a story about how we automated our network and migrated from our legacy service, legacy SURFnet 7 network to SURFnet 8. So Chris already mentioned it. Who am I? My name is Peter. I lived a long time in Australia, so you might recognize my accent. And at this point in time, I am a software architect, software engineer at SURF, master in system and network engineering, background in SRE. And about 5 years ago, I started at SURF as a trainee at the networking department. And yeah, the automation of networks was something that was a hot topic in the NREN world. So how can we make sure that we orchestrate network services so that we can move data from A to B, right? That's our core business. So the SURF network is the NREN of the Netherlands. It provides internet to around 1.5 million students, teachers, and scientists every day. And our commodity IP traffic is well, almost a third of the traffic that we do daily, but our main use case, of course, is data for science, and yeah, total network traffic is around 1.1 terabits, and we do actually see that our traffic is approaching normal statistics or normal traffic patterns after the corona pandemic. So that's very good news. And yeah, I guess the start of my story is that we recently migrated from SURFnet 7 to SURFnet 8. So our network is a network based on Juniper MX. Is a segment route MPLS network with a 100 gig backbone. And most importantly, obviously, as the Netherlands is such a small country, our most important points of presence are in Amsterdam, where we have most of our external connectivity, and where the Netherlight Open Exchange is centered. The Netherlight Open Exchange is a platform where multiple NRENs connect to transfer large data. And that node is part of a global architecture which enables scientists to signal layer 2 circuits across multiple domains through the AutoGol. So migrating from SURFnet 7 to SURFnet 8, how does an NREN even build a network, right? So that's where you start. A network is not only fibers, optics, routers, switches. It's thousands upon thousands of lines of configuration on the devices. And obviously you can imagine that there are lots of sources of data that need to be kept up to date. And as well as that, you have people, right? People need to manipulate the devices and make sure that configuration is entered into the boxes, and that data can flow from A to Z. In our previous network, SURFnet 7, this process took a very, very long time, right? It was a full-time job, and you saw that there were lots of inconsistencies creeping into the database. And yeah, the network was a network of configuration, not of customer services. And that was sort of the transition that we wanted to make from SURFnet 7 to SURFnet 8. Instead of focusing on making configuration for boxes and services and you name it. We wanted to make the transition to think about, okay, well, what is actually the purpose of our network, and can we more accurately model what we deliver to a customer and take that as a start. And I'll explain this concept a little bit further on in the presentation. So a long time ago in an NREN far, far away, that was the title of this presentation. Well, this is our data architecture for our previous network, and I'm not going to explain in detail what this all means, but it's basically a sort of a summary of how our data flowed, where all the data was stored. There was lots of cross-referencing and manual work, and yeah, it was a mess. Basically, that's sort of what you should take away from this slide. And if you think back to the people involved in managing this network, well, it was extremely difficult when a service needed to be applied to the network, or if a change needed to be made. It was basically an obstacle course for the people involved, right? They started over here, they needed to go through all sorts of hoops, go into this database, go into that database, make some calculations for the path computation, then apply that to the different NMSs, maybe even do some CLI provisioning, and then hopefully at the end of the day we had a working link or a working customer service. And well, people being people take shortcuts. I mean, if you take an obstacle course, at some point in time you're just going to say, well, what about this shortcut? It seems to work. We might as well use that. But the problem is that when you do that, yeah, you sort of mess up the process, and you start skipping things that may seem tedious, but are actually vital to keeping your information up to date. Because if you want to automate a network fully, you need your data to be sound. And I think that's one of the key things that we have learned in the past few years working on this automation platform, that taking ownership of your data, making sure you know where data is stored and how accurate it is, it has been key. And well, if you take shortcuts, well, I guess customer experience is also going to go down, right? Because you might miss something, you might miss a step, you might miss a step in procedure, and because there are so many people involved, yeah, there is a big chance in something getting lost in translation. So obviously this picture depicts the software, how software can be, how software engineering sometimes goes, and I guess you could apply that also to making a network change. Well, if you think back at the previous architecture or data architecture, well, we sort of said, okay, well, we need to figure this out and solve it. And what we came up with was this architecture diagram, where we saw the need for an orchestrator, which would be able to take data from all sorts of databases, so a CRM database, inventory management database, IP address management database. It also needs to know who's logging in and who's working on the system, and basically the orchestrator glues all this information together to be able to manipulate our network. And as you can see on the bottom here, we have a number of technology domains that we recognize within the service network, which is the optical domain, our service domain, which basically includes layer 2, layer 3 services, and our NFV domain, where we do some network function virtualization. And well, as we sort of thought, okay, well, we can probably scale this. We also foresee a future where we can sort of plug in extra technology domains to be orchestrated through our orchestrator. So our network integrates fully into all the services that the SURF as an NREN delivers towards our institutions. And well, as you can probably imagine, if you are an institution, you might want to see some statistics about your service. You might want to make some rudimentary configuration changes. Instead of going through our change process, you can probably just you probably would want to log into a network dashboard and just click the variables and make the change. And that's something that's actually we're very proud of, to be able to deliver to our customers, as they can now log into our network dashboard and make simple changes to their configuration, and that will be entered into our orchestrator and applied onto the network seamlessly and within a few seconds upon entering the change into the network dashboard. So if you think back to what the talk is about, right? So we're moving from device automation, where it's all about the device and how can I make this beautiful piece of configuration so that it works. We're moving towards services, right? So, okay, how can we make this very useful tool that can be manipulated by the customer, and is not about the configuration, but about, okay, what does the customer actually need? So our vision is that the automation orchestration platform is crucial for guaranteeing the consistent and predictable provisioning of services on our network, and it provides building blocks to be able to make composed services across multiple technology domains, right? So the holy grail is that you could define a service based on intent in our network dashboard, and if you need some cloud computing, you can get that as well. And if you need some firewalling or some network function virtualization, that will all be able to be built in the network dashboard and applied to the network on demand. So that's the reason why we're doing this. Well, as I mentioned, we started about 5 years ago, and we were starting to migrate from SURFnet 7 to SURFnet 8, and the effort really started with setting a number of goals. And the goals that we set were all changes onto the network must go through our automation platform. There must be no more CLI provisioning on our network, on our next generation network. And ideally, we would be in time with building the software needed to get that done before SURFnet 8 rollout. So basically, we had about 2.5 years to get this set up, and this was a mammoth task. Our migration started in the summer of 2019 with the installation of our 2 core routers in Amsterdam. And shortly after that, we did a fully automated migration from SURFnet 7 to SURFnet 8 through our orchestrator workflow, through an orchestration workflow. And after that, we were able to continually start migrating more and more services until we completed the last service migration early this year. And this was a mammoth task, right? Because if you think back to the data architecture, nothing was in sync. Lots of data was missing. And if you want to automatically migrate services from one network to another network, you really have to fix that first. So in those 2 years prior to the start of the migration in 2019, we had to really fix all our sources of truth and make sure our data was correct, to verify everything on the network, that it was actually how it was, so that we could trust the automation to migrate the service from one network to the other. And we were able to achieve that by really thinking about everything that encompassed the service. So really thinking about what has the customer got from us. So what did we give the customer when we initially built the service, verified that was correct, and then we were able to trust that to migrate the from one network to the other. And the fundamental shift that happened was that instead of trusting the network as, okay, that's the place where everything, what the source of truth is, that moved towards our databases, and we were able to trust that. Well, in the process, I guess there are a lot of things that we found out, or that we experienced as a team, and I guess this sort of this quote from Bill Gates underpins that. And the fact is that if you have an inefficient process, applying automation to an inefficient process will very much magnify that. And we learned this the hard way. It's very difficult to make a change on an inefficient process and then trust that automating that will solve your problem. That's not the case. You really need to look at everything that you do and make that change as well. So, I mean, if you think back from the timeline, what did we do in those phases? In early 2017, we evaluated a number of automation engines or workflow engines that could be used to orchestrate our network. And we thought, okay, well, maybe we can use a BPMN engine or some other tools. But at the end of the day, what we found out was that we might as well just build a homegrown application, which is what we did. It has been recently open sourced on GitHub, which there are some references at the end of this presentation. But we built our own orchestrator, which revolves around products that we provide to customers, and customers have a subscription to that product in our orchestrator. And while we were proof of concepting this architecture, we basically found out, well, I mean, 95% of the work that we need to do is done in the integrations between systems, right? An orchestrator is an orchestrator. It will just do its stuff. It doesn't really matter. It has a plan to check cycle. That's a relatively simple construct or concept. But the hard bit is like, okay, what does our data look like? How do I get data from A to B? How do I model everything? And if you look at our code base at this point in time, 95% of the code is in the integrations, and just 5% is just the orchestrator and managing the workflow engine itself. So once we decided that we would build it ourselves, we needed to standardize our data model, and we looked at using TM forum standardization. And in 2018, we made the choice not to use it because it was basically it's a very, very good model. It maps well to the orchestrator that we have. However, it is almost too well defined. We didn't need all the concepts and all the complexity that is in the TM forum standards, and we decided to make our own data model. And once we had decided on that, we started the big cleanup. It took us almost 2 years to clean up all our data, and we did that by one implementing our products. So going through all the services that we provide to customers, defining how they should look like, and then going into then fixing every service in our database. And it was not that they were all wrong, but it was just we needed to check that as much as possible. And of course, because you have an orchestrator, you can do that programmatically. So you can define how you think it should look, and we validated that. And if there was an error, somebody needed to go in and fix that error. Well, as I said, in 2019, we finally started migrating towards our new network. And along the way, as I mentioned before, the magnifying of inefficiencies, we started over a number of times when creating our workflows. And we also got a lot of our first workflows wrong because we tried to automate the process that we had in SurfNet 7, so the obstacle course, but instead of thinking about the obstacle, instead of thinking about an optimized solution, we tried to migrate the obstacle course, but as not everybody understood all the hoops in the obstacle course, and they were working with the shortcut method. It was very difficult to reach consensus about what a workflow should look like. And once we started focusing on the actual service that we delivered, suddenly we were able to cut 90% of the steps in our orchestration process and really keep the automation and the workflow to provision a service to the network lean and mean and very efficient. And yeah, I guess at the end of early this year, we open sourced our code together with ESNet, the Energy Sciences Network in the US, and they are actually also using our software in production to orchestrate their network as well, which is actually something we're very proud of. So challenges along the way. Well, I mentioned a few things already. You really need to change the way you think about creating services on the network. You need data integrity, you need new internal processes, and everybody needed to get used to it, right? So not only did we need to change the way we work, but also our customers need to sort of start getting used to our new terminology, a new way of working with our network and using the tools that we provide them. And a lot of people said to us, well, why are you guys doing this? Our network does not handle that many changes. Why should we even put this effort into this, right? And yeah, that was a tough battle to fight, because change is hard and people like the way things work, and why should we move on? Huh? So, but at the end of the day, we were able to achieve no CLI provisioning for SurfNet 8. So we moved from the left-hand side of the screen to the right-hand side of the screen. We built an app where people can create a product and rely on the fact that that will provision everything on our network, but also update all the database that we need to create a service. So our network does not handle that many changes. Well, I guess this slide we always use to sort of say, well, actually, that's not completely true. We've been able to do, for a moderately sized NREM, we've been able to do quite a large number of reliable changes on our customer products, so subscriptions through our workflow engine. And most of these changes have been done in our SurfNet 8 time, so from 2019 onwards. And it basically saves so much time, because if you think about it, if you did all these almost 14,500 changes in the old way, it would have taken quite a lot of time, but now it just takes a few minutes. And a large part of the reason why we can do that is because we validate our complete service portfolio every day with background jobs. So we fully check the network multiple times a day to make sure that the data is in sync, because there are some scenarios possible where due to an error or an outage, a NOC engineer needs to go to a box and make a change or do something to make sure that the customer stays online. But on the other hand, if you do that, we need to detect that, because then you cannot use that service, or you cannot manipulate that service anymore through the orchestration platform. And yeah, so we have quite a large number of products that we're able to deliver, and as I mentioned before, there's one other NREN that also uses our software. So I'm going to give you a short demonstration about what our piece of software does. And what you will see is that a person is logged into our network dashboard where they will make a change to an IP service. And then you will see the change be propagated to our orchestrator, and it will be applied to all of the systems that are necessary to update that to the network. And it takes a very short time. And this was something that took, in the previous network, the customer would need to send an email. Then someone would have to read that email. They would have to send a ticket to our NOC engineers. They would have to design that. Then they would have to create contact the customer to make a change window. Then the change needs to be applied. Then they would send an email back confirming that, et cetera, et cetera, et cetera. And this all now takes less than a minute, and it used to take a number of days. So here we go. On the right-hand side of the screen, you see our network dashboard. Person is logging in, and here you see our service details. Self-service is already activated in this portal, and the person is now enabling or disabling our anti-DDoS filter service on our IP subscription. And you can see now at the same time, the orchestrator has picked that up, and it is moving through its process or its workflow to change that subscription. And it's going through all the databases and applying the change to the network. And this change is real time, and it's almost done now. So it's updating the network, and any moment now it's finished, as you can see. So yeah, this is really a really good example of how we are adding features to the network dashboard that we have developed, so customers can really start using network services as a toolbox and applying changes on demand when they need it. And this is just a very simple example, but there are also more complex changes that are possible, like adding VLANs to a service or changing prefixes that are announced, et cetera, et cetera. So if we go to the next slide. So if you think back to our vision, an NREN needs to keep evolving and keep staying up to date, and orchestration is key to that. We need to make sure that we remain relevant in the future, that institutions still need us. And the way to do that is to integrate with HPC, cloud computing, firewall services, educational services, security services, campus services, maybe even. And yeah, the added value of a network is not only and no longer just its capacity or its capability to transport data, but also how it is integrated into all the applications and stuff that is around it, right? It needs to be an integral part of the services that we deliver to our institutions. And well, to link back to this conference, the usage of AI and network signals, right? So we have done some proof of concepts in the previous, a couple of years ago, with the usage of AI to predict the need to expand our capacity. And that was actually quite successful. We were able to reach quite a good level of correlation. However, due to the pandemic, of course, our traffic patterns got screwed up, and yeah, the predictions didn't really make any sense anymore. But as I mentioned before, everything's picking up now, and we might be able to start this up again. And one thing that we've quite recently started to explore is the creation of a rule-based engine where we would stream data from where we're probably going to start stream data from the network. And if we detect errors or stuff like that, we're going to propose changes. And depending on, so that would be the first iteration. And if the our NOC engineers sort of implement the change, or if they create a change, we will store that change and then use that as a reference to start proposing even better changes. And perhaps in the long term, we might even just allow the network to steer itself. So that's something that's very much in a gestation phase. We're still thinking about that. We're still, we're probably going to start with the proof of concept with that early next year. But because we have such a well-labeled data set and our data architecture is good, it's sound, and we are very sure that it sounds, we can start moving on to that. So that's something that's on the horizon. Yeah, and I guess we're almost wrapping up. I'm not sure how I'm going with time. Might be a little bit shorter than the time allocated, but this is sort of the vision and the architecture that it is of our platform at this point in time. So the orange bits are the open sourced resources that are now available on GitHub, and in the future we are definitely going to start integrating campus networking, our supercomputer, public cloud platforms, and yeah, trying to also orchestrate our optical domain. So I guess wrapping up, that's a presentation about our orchestration platform. I welcome any comments or questions.
Thanks very much, Peter. That was really cool. I really like the idea of you know, the changes that people used to go through before was like going through an obstacle course, and you've simplified it by cutting through those obstacles. Some of the things that you spoke about were similar to what Elon Musk recently said during his walk and talk around the SpaceX facility in Texas. He was saying that he tried to automate first and then discovered all kinds of problems afterwards. So he had to completely go back to the beginning and look at the issue. You like ask the right questions, then go through a process of reducing or removing steps of the process. And like you said, 90% of the steps that previously you jumped through, or those hoops that you jumped through, were removed. But how were you able to get buy-in internally to reduce some of those steps?
Well, a lot of massaging the right people and talking and just doing it, right? So you just need to start and show that it works. And I guess one of the key reasons why we had success was that we defined an architecture as our network teams, and we all bought into the idea, and we decided, well, we're just going to do it. And these are the guys who are going to figure it out. And it was not easy. Lots of people doubted us, but we just had to do it. And what you see now is that because we've done it, people are like, well, why haven't you done this yet? And we're like, well, hang on a minute, guys. 3 or 4 years ago, these guys were like, no, we're not going to do this. It's a bad idea. So yeah, it's an interesting process, but it's all to do with the people that work on the network, right? You need to get the people on board, that they buy into the vision, and then just do it. And it's funny you mentioned Elon Musk's walk around, because that's actually I looked at that as well, and I was like, oh God, this is amazing how he does that, right? And yeah, it's also an inspiration to really think about how you implement that. And I do think what he says is absolutely correct. You need to think about it first, then automate, and then do the optimization or whatever he said the order was. But yeah.
And have you seen an increase in the amount of users utilizing the new interface?
Yes, we have. So we started with so the network dashboard has had a number of generations. So I think we're on our third iteration of it, basically, and we are seeing a year-on-year growth at this point in time. And we basically released our self-service functionality early this month, and there already have been quite a lot of changes done through it. And it's the first few ones was like, oh my God, what's going to happen, right? So you're giving the keys of your baby to other people, but it all went well, which is actually quite cool, and it gives us confidence to implement more self-service changes. To make
did you see many errors that were introduced by the users?
No errors so far. So fingers crossed that it remains that way, but no errors so far.
I've actually got a question from Hirach that's in the chat, and he was asking, he wonders if you use OpenFlow protocol for the orchestration.
No, we don't. So we basically model our services through Yang. So Yang is the way you can model a network service, and we use our NMS. So our network controller is NSO. And that will, once you load that Yang model into NSO, it will provide a RESTful interface, and you can just apply the change to that RESTful interface, and NSO will atomically create the configuration across all devices that are influenced by that change. So
just for
NSO uses netconf to apply the change. Yep.
And just for the people who don't know what NSO is, could you explain the acronym?
Yeah, NSO is Network Service Orchestrator. It's a system provided by, it used to be provided by TailF and is now owned by Cisco. And it is a way where you can, you can model you're fully free to model your own network service. And through a templating engine, it is able to apply that configuration across any type of device that is able to talk netconf.
And is that open source?
No, it's not open source. No. So this is part of the RFP that we had for our SurfNet 8 network. Yep. The Yang models, however, there are a number of NMNs who provide their Yang models open source. They are open source. So the Yang models are open source, but this network service orchestrator software is not open source. Yep.
Understood. No, thanks very much, Peter. That was really, really interesting. Thank you.
No worries.
And so now we're going to head into a short break. So we'll be back soon at 12:15 CEST +1 or 11:15 CEST for those in Europe, and 10:15 for those on British summertime. So we will see you shortly, and thanks very much.
Hello.
Hi, we are waiting. There's a break now.
Okay.
So hello.
Yeah, you
Yeah.
can hear me.
You.
Can you hear me?
Yes.
Yes.
Good. Okay, I'm gonna try to share the screen.
Yeah, you can try.
Is this background working or not?
Yeah, partly. It's not very correctly, but
No, it doesn't work well. No? And this one?
it's not a background, I think.
Yeah, it's the blur stuff.
But your colleagues already, they have a good background with UIIP.
Yeah. We'll try to install it. Okay.
Yeah, nice to meet you, Pierre-Philippe, and your colleagues.
Okay, is it Chris talking?
No, Alexei. Alexei is
sorry, I didn't see.
Exactly. So nice to meet you again.
Okay.
Yeah, we will start in the 5 minutes because you see at the screen that it's 12:15. It means Minsk time, CST +1.
Hold on, I'm chasing this background because I have it on WebEx, but not on Zoom.
Send you an email quickly with this.
Can my colleague send me rapidly the background, please? So
I've sent you an email now with the background. An attachment.
Sorry, do we start at 1/4 or at 20 past?
So we will start in 3 minutes.
Is this working better?
No.
I think there's an effect of light here that doesn't make it happen well. So I will do this. How can I share my screen here to show the video?
On the bottom, there is green button, share screen.
I have reaction. Yeah, share screen. So can you see this?
Yes.
Yeah. Yes.
And you can hear me, it seems so perfect.
We can hear you, but I can't hear anything from the video.
Yes, because I will speak over it.
Ah, perfect. Very nice.
Okay, you only see the video and not any other part of the screen.
We only see the video.
Okay, good. Quick question to my colleague. Is there someone, everybody has his own slide or someone is clicking for you?
I am the clicker.
Okay, but how can people share their video and you share the screen? Does it work?
No, I will be sharing our presentation and they will have to tell me next slide.
Yeah, but can we see their face while you are sharing your...
I think so. I think so, in the corner somewhere. On the top right, you've got view and you can select.
Okay, my concern is that if someone takes the screen, the other one do not get the ability to talk. Was it validated this?
No, I can see you now talking and I can see the screen and also other.
Because I am the one sharing my screen, but
I can see others as well. So whoever speaks pops out.
Okay, so it's compatible then.
Yes.
Yeah, I can understand Andre. I can listen to Andre speaking and speak, I think. So it should be.
And see me. Okay.
So, dear colleagues, I'm happy that we're coming to the second part of the morning session. I was so excited with moderation of Chris. So now I will give him a floor. But first of all, I would like again to thank Irina, Hracha, Marek, and Peter, because there was super presentation in the first part of our morning session. And now, Chris, please introduce next speakers, especially so as for me, so I'm very fond of, I'm inspired with space. So I was happy that such, important persons actually, were agreed to be with us during this conference, International Conference on Pattern Recognition Information Processing Online Edition. Thank you. Chris, you have a floor now.
Thanks very much, Alexei, and welcome back, everyone. Thank you very much for joining us again. We do have quite a special session now, as Alexei mentioned, but this is a special presentation as well because it's in a hybrid nature with multiple speakers. Pierre-Philippe is leading the presentation from the European Space Agency team. He's also the head of the European Space Agency PhilAb Explore Office, and the PhilAb Explore Office at the European Space Agency is aiming to connect people, ideas, and digital technologies to help shape the future of Earth observation. And this is based in Frascati, in Italy, just outside of Rome. Pierre-Philippe has a degree in mechanical engineering, an MSc from the University of Liège in Belgium, and a PhD in oceanography from the University, and apologies if I pronounce this incorrectly, Louvain. Also from Belgium, and a management degree from the University of Reading Business School in the United Kingdom. He's joined by his colleagues from the European Space Agency, Bertrand, Daura, Andreas, Gabrielle, Govan, Raquel, and Isa PhilAb, I should say. Thank you so much for being here today. It's an absolute pleasure and an honor to have you here. And so over to you, the floor is yours.
Okay, thank you very much, Chris, for your invitation and also to have the opportunity to talk to this community about our passion. I'm going to try to share the screen here. Can I just check that you can see this video?
Yes, perfectly.
Okay, so in fact, today it's a teamwork. I have the privilege to lead a team of researchers in ESA looking at new technology and in particular AI. And they will show you some ideas we are trying to explore within our office. And all of this is in fact linked to what we call Earth observation, which is the ability to look at Earth and get the global picture from space. So as a space agency in partnership with the industry, the European Commission, etc., we are putting a lot of eyes in space, looking at the planet in different way, different perspective, different spectral bands. You can see here the type of data we are collecting, from the ozone hole to the condition on land, temperature, all aspects of climate, etc. Most of these data comes today on an operational basis from an infrastructure called Copernicus, which is a family of sentinels monitoring routinely our planet every 3 days in, again, different sampling, different type of electromagnetic spectrum. These missions are really operational, so you get the data all the time. They have also an open data policy. So the big opportunity here is that people outside have like 15 petabytes on the state of the planet freely available to them. It's accessible on the web. And the challenge is to mine these data to find information. And when you find information, you also can advance your knowledge on our planet, the climate system. You see here all the interaction for El Nino, for example, the impact of El Nino on the land, on the atmosphere, but also on the society. And you have also the ability to transform this information into a service and create a business out of it. Today, with the amount of data we have and the variety we have, the human operator cannot do the job anymore, and traditional method wouldn't work and wouldn't scale. So this is really the era of machine learning. It's hitting us very strongly, the big data in ESA. We were a bit late in the computer vision revolution, but there is really now a wave of scientists looking at this. And what we want, in fact, is to attract talent. So one reason we go to show this opportunity to the world is that we want you guys to work with us on these big problems of the planet, to help us find the patterns. Here you see a hypersurface of variables. So we work in a multidimensional space, and we ask the machines to find the patterns in this automatically. And then we put this together with domain experts to really make sense of these data. So there is a very amazing and exciting suite of problems to tackle with AI. We are not AI experts. We try to bring them to the labs, and you will see some of them later in the presentation. We try to merge this domain of geospatial data with the domains of machine learning, and some magic is coming out of it. Like this pattern here, you find a drought in Russia, and you can relate it to what's happening in the world, like the rain in Pakistan, for example. So this is called teleconnection. We have also many challenges related to computer vision, new paradigm of computing, etc. And I will leave the floor to my colleagues actually to go into more details. And I will remind the audience that there are opportunities to work with us. So please reach out to me on LinkedIn, via email, check the website of the Phi Lab. There are actually 2 vacancy notices for the moment, one on quantum computing and Earth observation, and one on new paradigms of computing and Earth observation. So I'm looking forward to interact with you, and I leave the floor to Bertrand.
Thanks, Pierre-Philippe. So, André will now share the slides. So please tell me when you can see them. Yes, we see them. You can go full screen and go directly on slide 4, please.
And please do tell me if you see the presenter mode or
yeah, that's fine now.
It is a good one.
Okay, great, perfect.
So next. So nice to be here today to make a short speech about the current great challenges we have in applying AI for EO observation. So I will be brief, or try to be, and introduce here some challenges which are really related to the people and to our environment. Indeed, the interaction between algorithms on people is really something that we want to focus about. First, from algorithms to people, we want to go beyond the paradigm of black box AI. Indeed, AI should be something that is understandable, that is explainable for the users. And conversely, we want people, which can be users, citizens, maybe entrepreneurs tomorrow, to be able to interact in the native language and very easily with the algorithms on the systems. And this because we have in mind a great objective, that is to build the digital twin Earth. Because what is needed now with issues like the climate change, for instance, is to be able to foresee what will happen in our neighborhood, in our countries, in the next years, maybe tomorrow, but also in 10, 50 years from now, and to be able to simulate what kind of consequences there will be if some parameter is changing, like temperature. Next slide, please. If we move a bit more into technologies, we have also great things to do on the lots of research axes we are investigating. Mostly, for instance, to leverage all the data that are produced every day by satellites and constellations of satellites. So we are looking a lot into unsupervised learning, for instance, on how to leverage unlabeled data. This, of course, has lots of implications, because if we want to reuse the time series of data that has already been acquired, we need maybe to use AI to enhance those products. And we will see later some fine examples of super resolution, for instance. And ultimately, I wanted to stress out also one of the things that we always keep in mind, is that the adaptation of the algorithms to the processor. Indeed, we can do onboard processing for satellites with very low resources. On here, we need to have really frugal learning and frugal AI. But on the other side, we can also have big computations to perform. In that case, we are ready to try how the algorithms can be implemented on supercomputers and even quantum computers. This is maybe the next big thing for us, and this is an axis we are looking with much enthusiasm. But now, I guess it's time for me to have the pleasure to yield the floor for Dawa, Andrzej, Gabriele, Govan, and Raquel, because we are doing great things and great stuff at the PhiLab, but all this is made possible by the great young talents from all over Europe, which are actually the true PhiLab. Thanks.
Thank you for the introduction, Safal. So I'm Dawa Derksen, and I'm going to talk to you today about my project on 3D Earth models from multi-view satellite images that I also did in collaboration with Dario Izzo from Advanced Concepts team at ESTEC. So please go forward to the next slide. So this project involves using multiple satellite images from different viewing angles, which you can see here at the top of the screen on the left, and incorporating all of these images together to create a 3D model of the Earth's surface. And so that goes very much into the direction of the Digital Twin Earth project that Bertrand was mentioning earlier, but also of photogrammetry or let's say DEM production in a general sense. So the idea is to take as an input these different images that are all captured from different angles, but also at different moments throughout the day or throughout the year, and to use them to be able to generate new images from unseen viewing angles and in unseen lighting conditions. Also to be able to generate an accurate map of the shape or the geometry of the scene. And sort of my new added thing that I added to this pipeline, which is already existing for a while, is the ability to also accurately map out the shadows and to take into account the variations in shadow position that occur in these images. And as a final output, we can generate a 3D model, sort of a standard 3D model made up of different polygons that can then be used for virtual reality applications, for instance. So what's nice about this method compared to standard, let's say standard photogrammetry, which was already existing before, is that it doesn't necessarily require stereo pairs, but it does require a lot more images than a stereo pair. And it's also able to produce a full 3D model instead of just a 2.5D model, like a digital elevation map. And it's also able to remove the shadows, like we'll see a little bit later. And so this was mainly the follow-up of pretty much a big breakthrough in computer vision, which was a paper that came out last year by Ben Mildenhall called Neural Radiance Fields, where they proposed to explicitly model light transport and to represent a scene as a neural network, as a continuous representation. So that was very much a big change in the world of 3D modeling. And so I added to this the aspect of being able to model the changes in light conditions that can occur, which is something that we have to face when we deal with satellite images. So please move on to the next slide, Andre. So here are a few equations. I hope you don't mind. So on the left side, we have the standard neural radiance field model, which was introduced last year. And so the inputs to the neural network, which is actually just a very simple multi-layer perceptron, although they do recommend replacing the activations with sinusoidal activations. This very simple neural network actually takes as an input the XYZ coordinates as well as the viewing angles, so the angles from which you're seeing the scene, and actually models the radiance as well as the density, so the geometry of the scene, as a continuous representation. And then these values are rendered using the equation that you can actually see below, which is pretty much a standard alpha compositing equation, which is also used quite classically in 3D rendering as well. And so on the right side of the screen, you can see what I changed to the model to make it compatible with changes in light conditions. And so instead of taking the viewing angles as an input, it takes the solar angles. So the model is aware of how the sun is actually hitting the scene, from which angle it's hitting the scene. And instead of modeling the radiance, actually model the albedo directly, as well as two extra terms, which are the visibility of the sun from a certain point, as well as the color of the sky that is also illuminating the scene. And in the rendering part, it actually resembles the other equation quite closely, except that there's a slight difference, which is that the scene is now illuminated by two sources, one which is a direct light source and one which is an indirect light source coming from the sky. So just to give a little number here, the sky light usually accounts for about 40% of the light when you're in the shadow. So that's why you can still get tan, for instance, even if you're laying in the shade. So please move on. Yeah, and here are some results. So on the top row here, you can see let's say the ground truth, so a real image of the scene, as well as the lidar measurement of the scene. And on the left are the results if you apply a basic nerf, which doesn't account for changes in light conditions. And as you can see, the shadows are very poorly modeled. And it also creates these sort of errors or artifacts in the shape of the surface. And when you actually go ahead and model these effects, let's say the changes in lighting conditions, you can see that not only are the shadows more accurately modeled, but also the surface shape is far more detailed. And another cool side, let's say side product or something else you can get out of this modeling is that you can actually then remove the shadows from the scene. And so this could be used for various purposes. So please go on to the next slide. And so this is the last slide. So for a little takeaway, what do you remember from this brief presentation? I was able to adapt a new paper which came out last year called Neural Radiance Fields to adapt it to satellite images where the lighting conditions change. And the end goal is to really learn.
Sorry, we lost you, Dara. Your
Yeah,
audio. Yeah, you're back.
Okay, somehow I muted for a second there, I don't know why. I was able to, so, okay, I'll just start the slide again then, all right. As a quick overview, I was able to adapt a new paper that came out last year called Neural Radiance Fields and apply it to satellite images where the lighting conditions actually change, so the position of the sun changes. And the end goal of this is to learn a full 3D model of the Earth's surface that's complete with the colors, but also that takes into account shadow. And sort of the way that I did this was to disentangle the appearance of the scene from the shape and also from the illumination.
And again?
All right, yes, I pressed space. I pressed space with my finger by mistake. I modeled the albedo, the sun visibility, and the sky color. Thank you. So if you want more details about this, please feel free to check out the YouTube video, which is about a 10-minute watch and goes into more details with the link here. Or if you really want the real nitty-gritty details, you can check out my CVPR workshop paper, which has this title, and there's also a link there, and also a few references. So thank you for your attention. And
thank you, Dara.
And yes, I leave the floor to the next presenter. Andrea, I think it's you.
Yes, so hello everyone, I am Andrzej Kucik, and together with Gabriele Meoni, we are research fellow at PHILAP, working on neuromorphic computing, which is one of this future of computing paradigms that Philippe Bertrand mentioned before. And now I let Gabriele start it.
Yeah, thank you everyone. Thank you, Andrea, for your introduction. Can you hear me? So today we'll discuss about the possibility of equipping satellites with synthetic brains. So next slide, please. We started this research by reviewing the possibility and the usability of deep artificial neural network for onboard satellite artificial neural network applications. So deep artificial neural network have the main advantages to have the high capability to scale to complex model that basically made them the state of the art for many computer vision and natural language processing applications. But they feature some limitations. So in particular, in addition to the limited biological plausibility, their main limitation is they are really computational intensive. And that usually leads to higher power consumption that may be prohibitive for some onboard AI, especially CubeSat applications, especially if you consider that the computational requirements in terms of energy double every 3-4 months for deep artificial neural networks. So in the field, we are reviewing the possibility to rely on a new paradigm. It's basically the one of spiking neural networks. So spiking neural network are brain-inspired models, and they are called the third generation of artificial intelligence algorithms. Their main advantages is due to their computational paradigm that doesn't rely on the separation of memory and computation, and also is massively parallel, asynchronous, and event-based. And you will see that when accelerated by neuromorphic processor, neuromorphic computer, they usually are really low power and also not energy efficient. Their main limitation is due to their lack of maturity that doesn't make them capable to scale to complex model compared to artificial network, but it's also part of the research. And so how do spiking neural networks work? So to understand that, you can take a look at the scheme that we have here, featuring two neurons, A and B, that asynchronously fire some spikes in red that are accumulated by the neuron C. As you can see, C accumulates a spike over the time, increasing its voltage V, that is increased until it reaches a threshold BTH. When it happens, the voltage is reset and the neuron C basically produces a spike on its own. So as you can see, the computational light on the spikes and it's basically sparse and asynchronous. And that's basically the sparsity can be really profitable of neuromorphic hardware, leading to energy efficiency usually. And about neuromorphic processor, now Andrei will give you a more insightful explanation.
Thank you. So, of course, to take the full advantage of this new computational paradigm, we not only need the algorithms, but we also need a specialized so-called neuromorphic hardware. This hardware, similar to the algorithms, is also asynchronous, massively parallel, and doesn't have, for example, centralized memory, just like our brains. And there is a couple of different groups which work on creating this hardware. For example, the Spinnaker group of Professor Steve Ferber at the University of Manchester, or the IBM's True North or Intel's Loihi. And some preliminary research suggests that, in fact, when we compare this specialized hardware to more standard devices such as CPU, GPU, or even some edge devices such as NVIDIA Jetson or Intel Movidius, we do see a very significant reduction in the power consumption during the inference. Here on this graph, you see it for keyword spotting. So something like when you say, okay, Google or Alexa, which is very important for it to happen on the edge. But anyway, how do we actually can explore this paradigm for error observation and use its advantage? So first of all, what is our motivation to even look at it? We know that because of the increasing computational requirements of deep learning, we will not be able to rely on this paradigm indefinitely in the future. At some point, we will run out of resources. So we need to look at different computational paradigms in order to facilitate AI of the future. And also, these computational resources significantly influence the CO2 emissions. So while we are trying to solve certain problems in Earth observation, such as human-made climate change, and we are at the same time, in some sense, contributing to them. On another point, there is now a growing market of small sats, which can offer new possibilities of space and Earth observation explorations. But because they have very restrictive power budget, we cannot really put very robust deep learning solutions on them. So if we want to equip them with AI, we need to look at different things. And indeed, we have carried out some preliminary research, which you can access by this QR code, to just see what kind of levels of accuracy for land cover and land use classification we can achieve. And what about the power consumption? Can we really have some gains there? And indeed, what we have done was to train a neural network, standard deep learning model on Earth observation data, Eurosat RGB, which comes from Sentinel-2, to get the highest possible accuracy. Then we converted this deep neural network into a spiky neural network and further trained it in order to reduce its expected energy consumption per inference, while at the same time trying to keep the accuracy levels high. So what were the results? Accuracy is still problematic. We have seen 7% accuracy drop, but let us remember that it was only trained in deep learning context. We haven't actually trained the spiky neural networks with that respect. But still, at the same time, we were able to gain 34 times the energy efficiency when we were comparing Intel's Loihi spiky neural network versus a GPU artificial neural network. So this is very promising and opens completely new avenues for deploying AI directly on the edge in space. Thank you. And the next speaker will be Gauvin.
Thank you. So, yeah, hello everyone. My name is Gauvin Lecuyer. I'm a research fellow at UIIP, and I'm going to present you this ongoing project I'm working on called Enhancing Sentinel View using AI super resolution. Next slide, please. So, super resolution is a task that aims to produce a high resolution image using a low resolution image. And the simple way to frame that is you have a low resolution image and you want to expand this dimension, but you don't want to just extend and add pixels. You also need to infer in some way the value of those pixels. And those methods that are called single image frame, single image or single frame super resolution. Next frame. So this has been done using convolutional neural networks with various strategy and various architecture, and more recently, generative adversarial networks have been applied to and show great results for this task. Next slide, please. But one issue is that one low resolution image can come from infinitely many high resolution images. And if you look at this small patch of pixel, it can come from this image, but it can also come from those images as well. And this is because downscaling causes loss in information. And so super resolution is a nilpotent problem because you can't revert it easily. And there is not only one answer to that question. So you need to find some way to constrain the reconstruction of the resolution. Next slide. And there is a lot of studies that try to do this by adding more images as in input. So use 2 or more images. And the assumption is that using more images will provide more information about the scenes that you are trying to reconstruct. And this is the method we are working on. So those algorithms have been tried on video. Using successive frame of video, you can have some subpart of the image that you can try to superresolve if there are close enough, or for stereoscopic data as well. When you have two cameras, one left and one right, that take pictures of the same scene at every time. So you have two versions of the scene slightly shifted. But we are we are interested into Earth observation data, and for this project we are specifically looking at Sentinel-2 data and the RGB bands. So Sentinel-2 is this cool satellite that provides Earth observation data with a spatial resolution of 10 meters. And all the data are public since the launch, so it was in 2016. You have a lot of data you can play with. We are doing, the method we are working on is a supervised learning. So we need some high resolution ground truth. For that, we use the Dove constellation run by the Planet Lab company. So this is a CubeSat constellation looking at that provide data at a resolution of 3.7 meters. But the issue with those data is that you need to pay to get access to it. Some challenge that rely with this task. The first one is you use several revisits over the same place, but you need to be sure that all the images you use as input are well aligned before being fed into the networks. Otherwise, you will input some blur, and deep learning algorithm doesn't handle that well. Then there is a fusion layer. How do you fuse the data to build a meaningful representation? And of course, between two revisits, you can have scene, changes that appears in the scene, some seasonal effect, and you have an example over the tulip field in Netherlands. You can have some weather effect with the clouds that can appear, the shadow of the clouds, and of course, the human activities can be seen from space, so it can impact a lot the inputs you get. We build our method upon the IRISNet architecture, which was proposed by Kaitis and colleague in 2019 from the Frontier Development Lab Europe. We are working closely with them to try to build upon this architecture to bring it to the next level. So it's composed of 4 components. The first one is the image registration, so to align all the inputs before feeding it into the network. Then you have the fuse and incl layer, which is composed of a convolutional layer and the fusing of the data. Then the layer will use the representation built in the previous layer to expand the dimension of the data, and you have the prediction layer that will infer the super resolution. Some results we get. So here on the left, you can see the Sentinel-2 data, some image of the Sentinel-2 data we use as input, the ground truth in the middle, and the results on the right. So you can see that it looks good. It works on those scenes because we have a lot of images that are clear and without any noise. But if you look at some scenes that are a bit harder, if you can, next slide please, like this one, you can see that the super resolved image is very dark and blurred. And if you look at the Sentinel-2 data on the left, can you click? Yes. So here are the 4 revisits we use. One image is completely cloudy, so it's discarded for the prediction of the image. But on the top left, you have a small cloud that projects a huge shadow on the ground, so it darkens a lot the image. And then the 2 clear images are quite different, and it's because of the vegetation that grown between the 2 visits. So when you combine all those 3 images, you get these noisy results, and that's why we are focusing our research now on this part of the problem. And next slide, please. And so yes, this is to summarize what we are doing in this project, and I give the floor to Raquel now.
Thank you, Govan. So hello everyone, my name is Raquel Carmo, and I'm presenting one of the projects I'm working on at the PhilLab, which concerns tropical cyclones. And this project is carried out in collaboration with PRIP'2021. Next slide, please. Because tropical cyclones are major natural hazards, their analysis and forecast is highly beneficial for policymaking and risk management. However, one of the most widely used techniques for tropical cyclone intensity analysis, called the Borak technique, remains largely subjective and dependent on analyst training. In the image on the left, you can see examples of tropical cyclone patterns assigned to specific intensity numbers using this technique. On a related note, L-band radiometers such as ESA-SMOS or NASA-SMOP and ESA C-band Sentinel-1 synthetic aperture radar now provide direct estimates of the ocean surface wind speed. Nevertheless, tropical cyclone category estimation remains a challenge, since on the one hand, L-band radiometers, due to their coarse resolution, are not able to capture the wind speed variation in the inner core region of the tropical cyclone. And on the other hand, SAR, due to the lack of observations collocated with reference data, still prevent an algorithm to be robust in all situations. For example, deciphering between rain and wind patterns, wind signatures. So building on this, this study explores the deep it's still in the first one, sorry. This study explores a deep learning approach to tackle 4 challenges. So the first one is to detect the epicenter of tropical cyclones. The second is to yield reliable estimates of their intensity based on topology patterns, that is on sea surface wind and rain related patterns. The third is to provide explainability on the categorization. And 4, to locate the center of the eye, as it is then used to determine specific information for a geographical storm quadrant. Next one. So using high resolution synthetic aperture radar data from Sentinel-1 and also data from L-band radiometers, we are exploring the use of state-of-the-art convolutional neural networks such as ResNet-50 on the top left diagram, or MobileNet V2 on the bottom left diagram, pre-trained on ImageNet for the detection and categorization tasks, and possibly region-based TNNs for the localization of the eye center. Moreover, this study addresses the explainable AI field by applying gradient-based class activation maps to better understand the characteristics of the learning model. And you can see on the bottom right an example of the use of this algorithm to explain the categorization between cats and dogs. Next slide, please. So far, we've achieved really good results on the detection task with an accuracy of 97% and a satisfactory performance on the categorization with precisions of 66. Here I present the confusion matrix from ResNet-50 on the categorization task, where the predicted labels roughly fall under or around the diagonal, although categories 2 and 5 seem to be the most difficult categories to estimate. We concluded that the quality of these results is mainly due to the amount of data we are using on the training, which is quite scarce for a deep learning problem. As you can see from these images on the left, the gradient-based class activation map successfully highlights key features of the tropical cyclones, namely the eye in the inner core region and the rain bands on the outer core. But we are still assessing explanations of why a cyclone is assigned to a specific category. As for future directions, we plan on implementing the eye center localization task, as well as the augmentation of the data sets using data from L-band radiometers, as a SMOS and as a SNAP, albeit having coarser resolution, special resolution. One other solution might be to test other machine learning approaches, such as few-shot learning. Furthermore, we're interested in possibly combining our deep learning framework with physics-aware modeling. This is where I conclude my presentation. Thank you for your attention.
Great. Thank you very much, everyone, for a mind-blowing series of presentations. I've got a few questions, and of course, to the rest of the people that are in the chat, please feel free to drop some questions into the chat window. I'd be happy to ask them. But my first question is to Dava. I wonder, with the model that you've proposed, do you foresee any other fields of scientific research that could potentially utilize the model that you've developed? And just to everyone else, if you could stop talking, please.
Yeah, there's a little bit of echo. I think it's coming from Dr. Nikos Ogonikolos. If you could mute yourself and if you could repeat your question, because I wasn't able to understand. Sorry.
Okay. Dr. Merkelas, if you wouldn't mind, could you stop sharing your screen for a moment? That would be great. Thanks. Sorry, my question was, with the model that you've developed, do you foresee any other scientific fields or thematic areas that could potentially utilize this model?
Well, yes. I mean, specifically for the shadow part, I feel like there could be a lot of analysis for instance, temperature variations in urban settings. So knowing where the shadows are going to fall, but also for planning out solar panel placement, for instance, that could also be another cool and interesting application. So solar energy. For having a full 3D model compared to just an altitude model would also be beneficial for understanding how wind goes through cities. So I would say, like in a general sense, urban planning would probably benefit from this kind of technology. Yeah. And then also in a larger sense, it would also be nice to use this for planetary exploration and to be able to build these kind of models of other planets as well in future projects.
And do you think that would have uses, say, for example, with identifying potential landing sites for, say, the moon or Mars or other locations?
Yes, absolutely. And also for transmitting a more compact 3D model that could even be learned on board a spacecraft, which would be very far away, instead of having to transmit all of the images one by one and doing that learning on ground. And
that ties in very neatly to my next question I was going to ask to Gabrielle. Well, yeah, it was more, as you said in your presentation, the new technology that you're using or that you've developed, the hardware that mixes AI with hardware in order to decrease energy usage potentially on satellites. That's quite a huge breakthrough, especially with getting a 39% reduction in energy usage on board. But you mentioned there about the accuracy was decreased. Do you foresee in the future with tweaks or future advancements you'd be able to improve the accuracy of the AI models that you're using?
Well, thank you for the question. Yeah, about the accuracy, one of the things is I was mentioning before is that those algorithms are still at a low maturity, especially the training algorithms is trying to support now, despite not biological plausibilities, try to explore backpropagation, but there are just last new year's applications about backpropagations, and that start to scale well to the bigger models. Still, the capability to scale to big model is not so great, and there's also part of the research to try to find new algorithms to scale well, basically.
If I may add one thing on that, let us remember that the current explosion of AI is just due to a single algorithm to stochastic gradient descent and backpropagation. And this entire edifice of deep learning is built on that simple algorithm. That algorithm does not exist for spiking neural networks as far as we are concerned. But we know that they have another important thing that we haven't mentioned in the presentation, and that is the way the layers communicate with each other. They don't communicate with simple numbers as in deep learning. They communicate with a sequence of spikes, which is essentially a wave. And in that wave, you can encode much more information than in a single number. So there's this missing puzzle of a good learning algorithm, but apart from that, we get excellent energy readings. It was actually 39%. It was 34 times. So that's just a mind-blowing number, yes. And apart from that, we have this opportunity to encode a very complex signals in the communication between the layers.
Thanks very much. We've actually had a question from one of the other speakers. Hirach asked, you spoke about energy efficiency, and I wonder if you're interested to evaluate the energy efficiency by using hardware like the DVFS and memory ballooning, etc., and software methods. Do you mean to go further for the, can you go further for the optimization, do you think?
Gabriela, you want to answer
that? Sure. And technically, I don't know the hardware that was mentioned by the person who made the question. So we would be open to evaluate other possible hardware or methods to evaluate the energy efficiency. That was also part of the research, and that's also why we call our research preliminary in the presentation, because we rely on some assumption to estimate the energy efficiency. So any kind of possible method, both hardware and software, to improve this aspect will be, of course, welcome. Thank you for this question, because it might be the starting point for further research, for sure.
And also, we want to explore different methods of quantization of the network, just to remove obsolete connections and to reduce the operational accuracy, to even further reduce the energy.
Okay, one quick comment on my side. The whole point here is it's really the access to this technology. I mean, it's the first time that basically AI can go to space so smoothly. We did an experiment with FISAT-1 last year, and we have demonstrated that off-the-shelf chip can actually run in space and run machine learning. So this is a massive jump between computer of the past that were radiation protected with very low computing power and the new generation of chip optimized for AI. So it's not really, for the moment, let's say, the optimization, it's not the main focus. The main focus is finally we can do machine learning in space, and this opens totally new opportunities. So if you want to work on these topics, please join us, because we are looking for talents, and we have a vacancy notice on a postdoc exactly on this topic. This is a topic which is totally agnostic. What we are doing in the lab is to take technology that are developed by mathematicians. I mean, Dawa mentioned breakthrough paper, and then we bring it to our field. So this is the tailoring of this, which is the key challenge for us, because geospatial is very complex. Remember, deep learning and computer vision was done for RGB. We are dealing with 100 bands here, and we need to make the most of it. So we have a lot of topics to address, and we need a lot of people to work on it, and it's very exciting.
And one other question came through on the chat, and that was, are there any spiking neural networks publicly available for examination at the moment?
If it's referring for observation data, yes, we have put a barcode in the presentation, and now we will share the link of our GitHub repository that is publicly accessible, and you can try our model and our code. Yes, of course.
Perfect, thank you. I did have a few other questions, but in the interest of time, I'll have to move on, unfortunately. Thank you again to Dawa, Gabrielle, Andreas, Raquel, and Govan, and also Pierre-Philippe. Thank you so much. It's been brilliant to have you all here today and speaking on your various topics.
Many thanks, Chris, and thanks for the invitation. Bye-bye.
Thank you.
Thank you.
Thank you.
And so now we move on to our next speaker. This is Dr. Nikos Moginopoulos. I apologize if I pronounced that incorrectly. He has a mathematical background with a diploma from the University of Patras in Greece, and delivered a postgraduate and doctoral research at Kharkiv National Economic University in Ukraine. Since 1987, he's been president, managing director, and shareholder of business entities related to information technologies, space technologies, education and training, management consulting, and business development in Greece and abroad. He's also an expert within the European Commission and the European Parliament and the Industrial and Employment Confederations in Europe, which is now called Business Europe. And yes, he's a senior consultant of associated technologies at the Panoplies and Western Greece for European issues. He's the creator of a PSPR, although I must admit I'm not sure what the acronym stands for, but it's Holistic Security Methodology. And he's received the European Business Award as a Greek National Champion for Innovation and Environmental and Corporate Sustainability between 2013 and 2015. His talk is about the information processing toward business and marketing improvements using blockchain technology. And so, Dr. Nikos, please, the floor is yours.
Yes, thank you for the invitation and the opportunity to speak in the conference. My subject will be the information processing toward business and marketing improvement using blockchain technology. It is a subject that it's interesting for different sectors, and for this reason. Additionally, first I want to give an introduction. You hear me well?
Yes, I was just going to mention that you might want to put the presentation into full screen mode, and you've turned off your camera as well, so we can't see you.
Okay. Okay. Yes, and about now it's okay, I think, with my presentation. And traditionally, trusted third parties guarantee the trust needed for various business exchanges between stakeholders. This creates significant additional costs for the transacting parties. As market grows, the need for a transparent layer of trust becomes mandatory. Blockchain technology acts as the missing trust layer in the evolution of the internet and in business development. Blockchain is to trust what the internet is to information. Blockchain methodology. It can be considered as a distributed database shared over a larger computing network. Copies of the shared ledgers exist in each one of the remote nodes of the network. Every block on the chain is a piece of data which have been encrypted. Why choose blockchain for business? Blockchain opens up a great number of benefits for business organizations because it is distributed, it is public, it is secure, it has low transaction cost, it eliminates intermediaries. Unprecedented advantage. It complex, robust, and high encrypted design ensures no weak points for exploitation by malicious acts against the network, data validity and integrity, a common environment of trust for every participant stakeholder. I want to add at this slide that especially for other sectors like research and space, blockchain is important because of this basic characteristic, because give opportunity for all this advantage to any database for any kind of formation, for any kind of transaction. Anticipated impact, because experts believe that the blockchain technology will have profound effects on the nature of companies towards how they perform basic functions such as marketing, accounting, incentivize people, their funding and management, and way they can create value. It is something that also we can have because of, in our conference, scientific conference, it is important that we can add information like also in for data in science and in others. There are a lot of similarities in the business, because business environment is environment that have the same need for any kind of information, any kind of transaction. I mean that in a business environment need also security, low cost, and transparency. For in the area of research, this kind of thing is more important because also, especially for international cooperation, need to share people knowledge and to share partial information because of confidentiality, and it is very important for any kind of things. Also, blockchain will affect all major business areas in the coming year, causing large-scale distribution to the global economy. General management, financial management, sales marketing, human resource management, IT, and cybersecurity. It's like a horizontal layer, the blockchain application, not have a lot of similarities with internet from the first period of internet. Because of it, it is necessary to understand all the people that blockchain create a new revolution after hundreds of years because of any kind of transaction. Or to be more concrete, to understand anyone from the audience about the blockchain, also for science and for space, is like blockchain finally, it's like a super lock system that no anyone can change everything, no anyone can do any transaction without information. Information processing, it is exactly what I speak before. Storage and exchange values are not saved in local repositories but in large peer-to-peer network. We know that peer-to-peer network do a lot of things, and especially when we have to say about space data or in other activities, it is necessary not to use over the cloud, but also to have, for security reason, a peer-to-peer architecture to support all the security for information process. Blockchain consists of an ideal environment for storing data sets or for artificial intelligence and machine algorithm training and processing, even in their encrypted form. It is also important because this thing with data sets for artificial intelligence, it's not a linear approach, but it is necessary to have support for cybersecurity using some standards, and blockchains will create a new standards for artificial intelligence because in a transparent environment, create secure that any process during the artificial intelligence algorithm training processing create different things, and also because artificial intelligence is something that using for human activities in science, in space, in business, or in defense, or etc. It is necessary to know that blockchain can secure this for any mistake or wrong process. Information remains available 24 hours, 7 days by anyone authorized. It's very critical for any kind of information that not to lose the data because of a new environment. Of course, it creates a difficulty because of the lack of speed of the infrastructure, because now blockchain work over the IP protocol on internet, but also there is a different experiments to see, for example, how we can use blockchain for data using narrow band for 3G or 4G, 5G, and also other alternative, also similar, like a new infrastructure for blockchain. I'm not sure that it is something that it will be feasible to do in next period, but something important to have in our mind. Participants in a blockchain can share, access, retrieve, and process data without harming the original record. Another thing, and we know, for example, in space, we sometimes we use satellite images or other data or from different sensors, but we use the originals, and we need to know all the steps, because if you have an image and do processing for different regions, sometimes it's necessary to see step by step in different phases how use the images and how can protect. With blockchain, we know every time that be in the original records everything that we have in our mind. Decentralized autonomous organizations maybe is the most interesting thing of for discussion for artificial intelligence and for machine learning, and also it is something cross-sector, because the focus shift from a state hierarchical centralized design to more decentralized approaches. A decentralized autonomous organization work independently with the combination of analytics, connected devices, distributed ledger technology, and smart contracts. Then, decentralized autonomous organization is something that we use in different things. Now name it technologies industry 4.0, or also you name it not like artificial intelligence, but more like like intelligence systems. And DAO can play this role because can be like can work in different cases, also during for scientific research or for sectors like space, because it's something that we can use in very advanced mode using the digital twin approach, because with DAO we can have a more neutral organization, and all the things is according to the basic the neutral according to the data sets that we have, and the all information process during inside of a decentralized autonomous organization give autonomy, but parallel with autonomy guarantee the security and transparency of everything there. It is okay. It is my presentation, and I'm waiting if there is any question from audience. I am ready to answer.
That's great. Thank you very much, Dr. Nikos. Please don't forget to turn your video back on. It'd be great to see you. One thing that I always think of when it comes to blockchain is that it's ideal for trying to gain an understanding of provenance of data. This has got a massive impact on certainly in the research and education field, for being able to accurately track and reproduce experiments. Do you see that blockchain and especially the new type of infrastructure that you're talking about could be utilized by the research and education community?
Yes, it is. Thank you for question, because very interesting. Because now with blockchain, I feel similar evangelist like with a period of internet of mid of 90s. Because mid of 90s, people, of course, the scientific society and academic using internet before the business and society at all. And blockchain, I believe that blockchain can create this kind of new infrastructure, especially to protect, to be more open and easygoing international cooperation for research and development and training. And also to guarantee that no any, for example, I can give you an example. One of the most important things for research and education is the IPR. About the IPRs, it is unique methods to use blockchain infrastructure to protect IPRs, because it would be in transparency over the net, and anyone can see everything and without any problem. Then the IPR is a good example how can use blockchain academia, and also how can, for example, European Union or United States or other countries worldwide, how to share this IP, the basic information, because blockchain can have partial information from a database. Then it's not necessary to share the whole database, but can be easier than to have a log file and the key to be in a database, to have access in US Patent Office or European Union Patent Office, because you can use blockchain like a common layer. The difficulty is different. The difficulty is that also if we have to coordinate, we know that in research project it's very not easy to use common standards for research from university to university or from research center to research center, or other organizations like European Space Agency before or Space Organization have a high level of security standards, and it is important how we can share with others. And blockchain can give us this opportunity for the scientific community to have easier access to this kind of information, to more sensitive information. And I want to mention one example, that one of our initiatives is to manage space debris using blockchain platform. Because space debris create for a lot of organizations from private like SpaceX, but from NASA, from Roscosmos, from ESA, and at least now we have a lot of traffic in space, and it's necessary to know about space debris. Blockchain will give the opportunity to anyone can share the critical data, critical information, not the confidential information, to have a map of the debris, space debris, and also to can prevent the new missions, etc. It's an example how blockchain can support the international research community in the space sector, for example.
And do you see that the blockchain, or at least the blockchain values that would identify a particular piece of information, would you suggest that that needs to be added to the metadata that comes with a particular data file?
No, it is now we have only one thing, that blockchain is so new and not standards for many things, also not standards for platform. People are confused because listen about Hyperledger or Ethereum or third parties that exist in the market, from technology point of view, hundreds of different blockchain platforms. My answer is it is necessary to wait a little to see, because my estimation is the next 1-2 years we will have more standards. And I can give the examples for your question, similar like on internet, from 93, 94 to interconnect databases with web. We need 7 years around to have the XML. Now anyone use XML for everything, including in research. But in the first period, anyone tried to have a solution how to interconnect databases with web. And when found the standards of XML, we had accelerate everything. Similar situation with blockchain now.
And have you, in the course of your working with blockchain, have you had any dealings with the European Open Science Card? Because there's a lot of work that's going on around standardization in that particular field. I just wondered whether blockchains featured in part of that work.
We try, all the guys in different areas we work research for blockchain, we try to be evangelist for it, but I'm not sure if we have success anytime, because there is a confusion in the people, also in the society, that anyone when listen blockchain thinking about Bitcoin, but it's not correct. Bitcoin is like the rabbit of blockchain, and anyone know to have profit and to have more money mining Bitcoin, etc. But for this reason, need a little more time to the big players. But of course, for example, about Bitcoin and fintech, it's also important that the European Central Bank decide to create a legislation for cryptocurrency, because cryptocurrency is only a small part of blockchain. And then we should see how to thank the conference, because have this opportunity to explain to the people that blockchain is different, not only crypto, not only Bitcoin. Unfortunately, also in scientific society, no anyone except guys in our sector, in IT sector, know what's happened. They believe it's something too early or too different or like a game, but anyone believes that internet is a game before 20 years.
No, I see the problem. No, and just to say thank you very much for your enlightening presentation.
Chris, Alexei is speaking.
Go ahead, Alexei.
Words. So, Dr. Nikos, so I'd like to say hi. So I'm happy to see you now. Yes, because Dr. Nikos actually, so he's always full of ideas, big ideas, and I'm very fond of his space ideas and UAVs, which are connected to UAV. But I would like to remind to all of you that we also have a YouTube stream now, and we have a question from YouTube chat. So of from one of our speakers, which was yesterday. So, dear Nikos, what blockchain projects are realized in Greece and in what sector of economy currently? So probably it's like continued working what was said. Yeah, please.
Yes, until now we have implemented blockchain not only in Greece but also in Netherlands, because Aratos Group have companies in Netherlands, and already we had implemented in the administrative sector for municipalities for document management at highest level. But the most interesting thing that we do until now is about waste management using blockchain. Waste management is important because it's the sensitive thing like environment, and doing the job to using blockchain to guarantee that the waste coming from one place to other. And we had implemented similar with waste management between Belgium and Netherlands. And last but not least, especially because of COVID period, we see solutions for medical ID using blockchain because it fits better the GDPR from European Union, and then using blockchain guarantee also that we have to implement it in this critical period. And I want to mention for the audience also that exam not only from Greece or from Belgium, but not from European Union. After Brexit, United Kingdom, because have more freedom for regulation, starting to create blockchain infrastructure to manage vaccination. It's very important. It's an example that technology can apply easily with low cost.
Thank you. Yeah, I think it's clear. So again, thank you, Nikos. And so, Chris, you may proceed, please.
No problem. Thanks, Alexei. And thank you again, Dr. Nikos. It's a pleasure to meet you.
Thank you. Bye.
And now we move on to our last and final speaker, UIIP Bilic, who is from Cornet. UIIP holds a master's degree in economics from Josip Juraj Strossmayer University in Osijek. I think I've pronounced that correctly. He's nodding. He began his career in 2001 as a translator for the United Nations. He soon became the coordinator of educational projects in the non-governmental sector, where, among other things, he led the project New School, Integrated School, Vukova, to establish the first integrated and intercultural primary school in Vukova. During his work in the non-governmental sector, he gained extensive experience in the development, application and testing of educational projects funded by the European Commission, the World Bank and the Kingdom of Norway, the Republic of Croatia and other large donors. After joining CARNET, which is the Croatian Research and Education Network, he took over the position of expert in EU projects. He's participated in operational programming in education for the operational programs called Competitive Cohesion and Effective Human Resources in the Republic of Croatia. He initiated and led the development of the eSchool project, which is the largest informatization project funded by the European Union. I can't even say that, and I'm British, which digitally transforms the teaching and business processes of primary and secondary schools and raises their digital maturity. He also led the cooperation with the European Investment Bank to invest and develop in an e-school project following EU regulations, digital educational programs and strategies, and national indicators. And in July 2001, he was appointed as Vice CEO of CARNet. His presentation is called Do AI Dream of Electric Sheep? So Uri, the floor is yours, and over to you.
Well, thanks, Chris, for this introduction. It's actually 2021 that was named, not 2001, but for Vice CEO. But anyway, let me share the screen first with you. Does everybody see the presentation?
We see it, but it's not in presenter mode.
Okay, let me change.
There we go.
Is it okay now?
Yeah.
Okay. Well, first, thanks everybody for listening to me, and thanks to organizers for inviting me to talk. The question here is, of course, what do we do with education systems regarding artificial intelligence, which is here to stay? First and foremost, as Croatia has become the part of European Union, we use the large amounts of funds available to us to develop the national project of e-schools, which is actually the implementation of ICT in education. And one thing that we should all be aware of is that implementation of technologies, new technologies in education is always, among other things, damage control, because technologies are disruptive. Education, however, is something that has been mostly unchanged in the ways of methodology for last hundreds of years. So this is something that we had to think about all the time regarding ethical issues and other components that technology disrupts when introduced in education system, especially among younger students. Here you have some information about the European investment in AI in future and about the forecast, what will AI, how AI will disrupt the market regarding its revenue in the next years. It is important to know that all EU member states at this moment are either developing or already have developed AI strategy. All of those documents are mostly live documents, which will always be again rechanged due to new developments in AI and new issues that are being brought up. We are still implementing this project e-schools, 200 million euro worth. But one of the things that our ministry has asked us as the state agency in charge of education, ICT in education, is to see how we can address the issue of artificial intelligence in problem solving in education sector. When we say about problem solving, anybody of you acquainted with education systems would know that what ministries always want and state wants is to be efficient, to use less funds and obtain better results. And sometimes, even naively, they think that algorithms or advanced algorithms, which I assume call AI, could be used in better human resources, in better implementation of the funds in education system, and so on. Now I will give you some examples of problem solving in education. We all think that AI can be used for personalized learning, and it is used by many players in the education sector. How does it work? Unfortunately, sometimes it works as self-fulfilling prophecy. What does it mean? A pupil or a student gets low grades, and an algorithm curates content and actually provides content of lesser and lesser demand, intellectual demand for the same student. And if you have this kind of AI, it becomes self-fulfilling prophecy, where it could become self-fulfilling prophecy, where a student will get less and less demanding tasks. So this is something that we should be very well aware of, that AI has a bias, which is either the bias of its developer or the bias that its developer did not foresee. Then you have automatic solution for evaluation, providing the solution procedure. Photomath in mathematics. You can download Photomath on Google and App Store, for example. It is a very interesting project, and you can see how it helps your mathematical development. And also you have self-assessment and comparison of students at the national level. Then again, this could also be problematic. And here I will mainly talk about problematic issues of AI. Why? Because as a state agency, we have to make sure that all the possible bias is excluded when introducing anything into something so fragile and so important as the education system and young people. What can go wrong with comparison among students? If you say that you will fund schools with better achievement through self-assessment more, and those schools with pupils with lesser achievements you will fund less, in the end it is again a self-fulfilling prophecy. And now we get to this main issue that we, before even developing the project of AI, asked. Here you have some definitions of what is artificial general intelligence and what is a super intelligent AI. And the second issue is something that we try to tackle the most. It says a super intelligent AI will be extremely good at accomplishing its goals. And if these goals aren't aligned with ours, we have a problem. I assume that the organizers will forward my presentations to everybody interested, so you can also see the links that go into more details about what we tackled. But this is very important point. We have to make sure, if you use AI in education, that it is aligned with our goals, and our goals are goals of education system. And one of the articles in Croatian Constitution says that all pupils, no matter where they live, no matter from which class or society come, have to have the same access to the same quality of education. Now the two next slides, this one and the next one, are the high risks identified by European Commission. So these are the high risks identified by European Commission. As you can see, European Commission also placed on the second most important risk, educational vocational training, determining the access to education and professional course of someone's life. Something that I already said, if you use AI without understanding its possible bias, without making sure that this bias is excluded or tackled, or that in the end you have a person, a teacher who will make sure that AI is not the final corrector and final decision maker, AI can in a way damage somebody's educational path. These are the last three high risks that the European Commission has identified. You also have a link to all those in more detail at the end of the slide. Well, now this is something else that we talked about extensively. I will now also point out that this is something that cannot be done by a state agency by itself. In order to develop a project that is concerned with AI for the education system, you have to involve pedagogues, psychologists, ethical thinkers, and other people who may contribute to how to address AI in education system before you even start designing a project. So first thing mentioned by me already is that AI can be biased. Second thing is that we should avoid competing with AI. AI is much better than humans at processing information at scale. So let's not compete with AI because we will always come out as losers. So what do? That's the next step. Build skills that only humans can do. So let's focus on human side of people in education system and use AI as a tool, not as an end mean. And then, of course, the next one addresses also this, that humanity is a competitive edge, not a handicap. Problem of bias is something also UNESCO has addressed. There are many challenges in harnessing AI. You also have a link where you can read more about it. And solution that can be used to address the biases, improving data collection, improving tools and resources, openness and incentive structures, and broaden the community. This is something I addressed earlier by saying who could be involved in development of such a project. But also in the end, and I would add one point, make sure that the final decision is made by a human being, not by AI, at least in education projects or education system. Here you have a link to the paper about AI bias algorithm affecting the education system. This is something I think everybody ever wanting to use AI in education as a possible tool to assess somebody's grades or somebody's achievements should use and be aware of. The next thing that you have to take into consideration when developing the project of AI in education system is how to motivate students to get acquainted with AI. How to teach future generation what AI so that they can make informed decisions. This is something that we already know, which we don't need AI to know the problem. All of us go to YouTube. We know that what we choose in the past defines what YouTube will provide or offer us in the future. So in a way, we think we are in control, but if we are not aware of this, actually your past defines your future and defines what you will look at and what will inform you in the future. The third thing is something for the future market. And the fourth thing is something that all in education sector know what I'm talking about. That is that the concept of lifelong learning. You cannot say this one moment, okay, I know everything about AI or algorithms, I know how they work, I don't need to educate myself anymore. No, you need to be in a way aware, conscious, and educate yourself for the rest of your life. Okay, so now more in detail about what CARNET as a state agency in charge of education thought. We need to make the introduction into systematic education on AI. I will talk a bit later more about this, but what we have decided on is defining two curriculums actually. One, informing the students about what AI is and what does it do, and then perhaps selecting interested students to teach them on how to use AI. So teaching about AI is for everybody, but teaching on how to use AI, how to program or develop AI is not for everybody, but for those who are interested in doing it. The other thing that we all need to do is encouraging research to the application of AI in education. What CARNET can do, because we also hold all the data about the students in Croatia, mandated by the law, we can open some data in line with GDPR and privacy laws that Croatia has, open to research so that we can be provided meaningful assessment and research done by researchers interested in what does this data point out. And so this is something more on project level, but we always believe that first you should pilot your ideas before large-scale implementation on national or regional level. I already talked about the first point, curricula about and for AI, which is very important to and I stress out it again, all pupils, all students should be taught about AI and its implications. Cross-curricular topics, equipping schools. In a way, we already did equip schools through the project of e-schools. Open systems, organizing competitions for schools and training the trainers. The last thing is something that actually I should have put above. Who will teach the students about this? Well, of course, they're teachers. So the first go point for everybody who wants to input AI into education system is to make teachers aware of its implications and teach teachers about AI. Let's not forget, in education systems, no matter what technology you implement, or the teachers are the one that will be conducting the education. So if you don't invest in soft skills of the teachers, in education, in upskilling of the teachers, no matter what equipment you provide, no matter what curriculum provide, teaching scenarios, if you don't invest in teachers, you will not get the results you want. This is something on how to involve researchers on the application of AI in education. I already talked about it. These are some steps on how we thought we could involve the teachers. Of course, it helps if you are in the position of CARNET, which holds all the data about all the pupils and students in Croatia. Here's one example of what we have thought about in establishment of the AI in education system. The general goal is, I think, self-explanatory. And now there are specific objectives. System of testing and self-testing. What we have concluded, that system of testing and self-testing is good, but it should not be something that will determine the future of the student. So if we provide something as a tool, it should not be at the same time something that will define its students' grades fully. The third point is also important. Develop models for monitoring students' results. Again, yes, but again, the teacher should be the one, the last decider, not the algorithm. And the fourth point also addresses the third and continues on the third. And now, where the current status of the project of AI in education is. It is a complex project that requires a special line of funding. It means that these kind of projects also need funding that is specific to its purpose. Croatia is lucky that it has the large amount of EU funding. The second thing is dividing the project into smaller segments. Why? It is much better to have a modular project because, to be absolutely honest, if something goes wrong in one module of the project, you can always change it or even scrap it. But if you have a whole project funded and predefined, then the whole project is in a peril to not be conducted as it should be. So it's much better to have modular projects. And yes, parts of the project are integrated into other and planned current projects, while funding is sought for the rest. To be perfectly honest with you, we are still thinking of how to apply AI in education without endangering the educational process. And I think that's the right approach because many obstacles are still not really defined. And when introducing something this disruptive, we should all be very, very patient in introducing it. Thank you all. That was my presentation. Chris, if there are some questions, I'm here to answer.
Thank you. All right, that was great. Really, really interesting on how AI can impact on education. And I mean, for me, just listening to you, it brought to mind that, well, one of the questions I've got is, do you think that the legislation that's required to keep AI manageable for citizens can actually keep up with the developments of the technology?
Well, that's the question for policymakers and for ethical, let's say, mentors. But in my opinion, we have a big problem here. AI and technology is developing in such a fast manner that, yes, usually the state legislation, especially EU legislation, but also the state one, especially for EU member states, is always a step behind what happens. And the thing is, while we develop some concepts or some agendas or some directives by European Commission, AI is already 3 steps ahead. Let me just remind everybody that a few weeks ago, China actually banned the use of mobile devices for children for more than three hours per week. Of course, China, as a more central state, can do this, but obviously that the thing that we have seen that are problematic are sometimes better addressed in a more centralized planning system than unfortunately in the European Union. But yes, the legislation should be much faster in tackling the things that technology brings. Absolutely, yes. I don't hear you, Chris.
Sorry, I had myself muted, which yeah, sorry about that. And yeah, one of the questions from that,
Chris,
it
your
was quite
connection is very, very weak, and I didn't hear you well. Sorry.
Focusing do this, the legislation for AI. Oops.
It seems we have some problems with the last mile, the Chris line. Yeah.
Sorry, my hello.
Now it looks
sorry
like
about that. I pressed the wrong button on my laptop.
Yep. So, can
you hear me okay?
You're right. Do you hear me now?
Yes, I do hear you.
Yeah. So yeah, we see that some problems occurred with Chris' internet. Well,
okay.
So one way. Okay.
Sorry about that. Stabilized.
Hello,
for everyone.
Yeah, something still goes wrong. So I probably while Chris trying to reconnect or something will speed up his internet. Good afternoon, Uri. So I'm very happy that you're with us, and actually, so I'm so happy that you resonance in DNA of conference so deeply, so clearly. And I remind that tomorrow we'll have a panel discussion, and so you invited to be a panelist. Yep, and so we will shortly go with your state, and probably other scientists will try to argue or agree with you. It will be nice, and I hope we'll have a quite clear discussion. I also have my own opinion, which actually quite similar to you, but who knows? Tomorrow we'll have scientists in the field of medical informatics and biomedical informatics. Yes, bioinformatics, and we'll also have Russia here. I hope he will join us tomorrow, and we'll talk about AI and information society, legislation problems, and of course problems with education and well, this triangle: business, education, and industry. So it's very important. And what was today, what I saw today during your presentation was so just brilliant. Thank you, Uri.
Thank you. I just want to say I'm not a scientist. We are more.
Yes, that's why the panel could be quite, provocative. I hope it will be provocative.
I also hope, and the reason is that when we think about the education project, we really should think first about the students and then about the technology.
Mm-hmm. Yeah, thanks. So, Chris.
Yeah, I should be back now. Apologies for that. My laptop decided it wanted to start doing an update just at the crucial moment when I was about to ask another question. But no problem. You're right. Thank you very much. It's a pleasure as always. And just to say to everyone who's connected, thank you very much for listening to all of the presentations today. We've had quite a wide range of different subjects, from network automation, space, Earth observation analysis, education or use of AI in education, blockchain, and many other topics. I think it just goes to show that the field of AI is quite broad and is a new greenfield area for a lot of research. And with that, as Uri mentioned, there's the implications, the ethical, legal, and policy implications that come along with it. But yeah, hopefully this session has given you all an opportunity to think about some of these challenges that are coming to prominence. And yeah, as I kept thinking today, Steve Jobs once said that the computer was like a bike. In a way, AI is like the next gear on the bike to accelerate it and make it go faster. And I think, yeah, the presentations today have adequately shown that that might actually well be the case. And so I'd like to thank everyone for the participation, and thank thank Alexei and the rest of the committee that's selected all of the talks and put this session together for having us. So
yes.
Alexei, over to you, and thank you very much.
So from my side, so I'd like to thank you. Many thanks to you, Chris, because you're the best moderator ever. Yes, and the session was brilliant. It was nice. Actually, so in Minsk now it's rainy and it's quite gray and sad. And the session, I'm not sure what. So okay, what is the weather in Amsterdam now?
In Amsterdam, it's currently gray.
Gray? So, but our session it was not so gray.
Mostly gray in Amsterdam. It's mostly gray.
It's always gray. No, it's not always gray. I shouldn't say that.
Yes. So I think all of our speakers, I would like to say again, thank you, because it was so nice, and so thank you, GÉANT. So because with the help of GÉANT, we have actually this Zoom Unlimited edition for our conference, as well as, of course, speakers of these sessions. So and now probably, so I'm just trying to finish this session. Okay, yes, Chris? Okay, so I'm just announcing that after the break, which will be in 2:45 Minsk time, we will start next session dedicated to theoretical part of pattern recognition and information processing. We have done after the briefing break, we will have practical part. So okay, so from my side, it is all. I would like to suggest you to go to have a cup of coffee or physical exercise, do physical exercises, and come back to 2:45 Minsk time, means 1:45 European time. Thank you all.
Thanks, Alexei, and take care.
Take care the same. So I think it was okay. Yes, yeah, we still have a YouTube stream. Also, we have a Telegram chat, so our speakers and audience may ask questions there also. So, yep.
Yeah, I'm sorry about the laptop. It just decided to do a security scan right at the last minute, and it drives me crazy. This has happened before, and I had it turned off, but it keeps turning itself back on automatically.
That's okay, actually. So because in the morning we also had some kind of technical routine issues because of YouTube, because of sound, and so on. So because we have not so big team to arrange all these issues. Yep.
No
yeah.
problem.
Yeah. Okay. Well, I can show you probably if you do not mind. I can show you a bit. Backstage of us.
Yeah. Lovely. Yeah. Oh wow. Hello.
What we have. Yes. Big audience.
It would have been great if we could be there live. It really would. It's a shame we can't be there.
Okay. If somebody wants to give a feedback now, you may unmute yourself and tell us something about this session, or just go to the to have a lunch.
And just to say, I'll need to drop off in a moment because I've got another meeting now.
Yeah, of course. Yes. You're free now.
Please feel free to let me know. I'd be keen to hear.
Okay. Thank you.
And as it's quiet, I'll bid you all adieu. Have a lovely lunch and the rest of the day. Take care.
Sure.
Okay, so good afternoon, dear participants.
Let's start in 1 minute, okay? So I'm sorry.
Okay, so the delay is on the side of organizers. I guess they have some technical problems.
Right now, yeah. Dear colleagues, so good afternoon. I hope you already enjoyed your lunch. And now we come into the session A3, which is dedicated to the theoretical part of the pattern recognition and information processing. So now I would like to give a floor to our distinguished session chairman, Professor Alexey Kharin. So, Professor, you have a floor now.
Okay, thank you for giving me a word for introduction. So our session is related to many things, to pattern recognition and classification first, to knowledge-based expert and decision support systems second, and also to application of pattern recognition. According to the schedule, we have 6 presentations. I can identify authors of 5 of them here, and I hope the presenter of the talk number 5 will appear, if not yet. So we are trying to go on the schedule, and according to it, the first talk is by Lyudmila Cheremisinova and Dmitry Cheremisinov on correctness of control systems with concurrency behavior. Yes, please.
Good afternoon, colleagues. So I want to demonstrate and would like to present the topic correctness of control system with concurrent behavior. The considered task is functional verification of digital systems with parallelism of behavior. And verification we understood as checking whether an implementation of the control system conforms to the function specified on its specification. This task is very important because of digital systems grows very quickly. And so the complexity of testing tends to grow and grow faster than the complexity of design. Ideally, verification would have a result to find out all bugs in the implementation. That is exhaustive simulation, but exhaustive simulation supposes that we reach each state and all possible input combinations of input signal, but this task is exponential on complexity. And the outcome is to restrict this process. So do it within a visible type. And one of the ways to restrict the exhaustive simulation is to generate test pattern that cover restricted area of all patterns. For example, to generate patterns that cover only those area of function in the system that is reflected in its specification. So we use model-based testing. In model-based testing, the tests are generated from its specification. Then we have implementation of the control system that we see as black box. Its internal structure is not accessible for us, but it can be fed by test patterns, and we can see the outcome of fulfilling these tests. And if all patterns are good, and the outputs of test stimuli and outputs of the implementation are equal, so the set under test conforms to its model reflected in its specification. And the object of our consideration are reactive control systems with concurrent behavior. That system have the following peculiarities. First, continuous signal exchange with external environment. And the second, concurrence of the processes occurring in the system. So in that case, we have so-called true concurrency, when concurrency is reflected in the specification. Such reflective systems are asynchronous in the nature, but they have many implications in communications protocols and in industry when we have industrial algorithm of control. The well-known ways to describe control systems are finite state machines and label transition systems, but the languages have not all expressive means to reflect true concurrency. The models that reflect true concurrency are connected with Petri nets. That is the known methods to reflect true parallelism. So the languages of colored Petri nets are used, and parallel automaton and parallel algorithms too. Methods for pattern generation are based on traversing automaton graph or reachability graph for Petri nets, but the methods are based on state explosion, and we propose the method of simulating reflective control system with concurrent behavior without these difficulties. What suggested? The goal is to generate test sequences for verification of reactive system with true parallelism. We solve the following problems. What can be language to be able to explicitly reflect true parallelism in specification? And how to verify control systems with parallelism without exhaustive computation? How to organize verification of system with concurrency behavior using sequential computation? And how to generate test sequences that ensure visible time limits generation and good coverage the area of system functioning. And we suggest to use PRALU language for describing parallel control algorithm. And we use this language not only for system design specification, but for describing behavior on the object controlled by the design system. That we use PRALU protocol for describing the control system as a whole. That is control algorithm, control device, and the controlled environment too. Then we propose to use specification for restrictions the area that should be covered by verification. Then we dynamically the process of simulation. Then we generate test sequences dynamically in the process of simulation and debugging the specification before its implementation. Parallel control algorithm in PRALU. So the main features of this language, it uses an ordered set of chains. Each chain has initial and terminal chain labels, so-called partial states. Partial that is considered as states that can be simultaneously. So the full state consists of several partial states. All variables of the algorithms are Boolean, and we used there is two basic operations in PRALU algorithm, waiting and acting operation. Waiting for the time when the conjunction is equals 1, and acting assigning variables to assigning values to variables from the conjunction. So the chains as can be executed concurrently or alternately. Alternate branching, that is one of the chains can be fulfilled in the next moment of time. Here is a simple example of parallel algorithm that describes the cycle of manipulator that moves from right to left and from the left to the right. And it reacts to the external signals only in right-hand position. Then if the button enable was pressed, then it continue its motion. When the button disable is pressed, then it stops. So the algorithm is very simple. It contains two concurrently executed chains. One chain defines the control stimuli for manipulator, and one states the button, pressing the buttons. The problem is how to simulate reactive systems that have parallel processes using sequentially operated means. And we suggest interpret parallel algorithm by a transistor level model. For this, the interleaving parallelism model is used. Concurrency we understood as the ability to order operation in arbitrary way. Then the semantics of waiting and acting operation is refined. The refinement extends the definition of partial order of implementation to a linear order. Then we organize algorithm interpretation, the notions, and to organize algorithm interpretation, we introduce the notions of branches and the quinius. And to organize process of branch execution, waiting and acting operations are considered as compositions of some elementary operations. To synchronize branches execution, the barrier mechanism is introduced. In such interpretation, parallel algorithm can be executed in linear time. That is the property of linearity we provide. Data structure. Data structure of parallel algorithm in Teleum model consists of two vectors of variable values. One vector current values and the second planned values, that is values for the next cycle of simulation. And so the operation are introduces on vector components. The central notion of simulation of scheduling procedures of computation with linear ordering is a branch and sub-processes. Branch is understood as a set of sequential sub-processes that start with a given operation and can be executed in parallel. Branch is dynamic object that can be formed, terminate, executed, and suspended. To organize, to schedule the processes of executing branches, the notion of quinius is introduced. The quinius of ready branches for execution and the quinius of waiting branches. That is, the ready for execution branches are fulfilled in the present cycle, and the way quinius that the branches that will be executed in the next cycle. Так, barrier mechanism. The barrier mechanism at the points where operation must be suspended. Значит, and the central point of the barrier mechanism is the agreement about the duration of the language operation. We use the assumption that all operations have zero duration. Using these assumptions, all the branches are executed until they can. And the end is when it demands the new values of variables. The algorithm of simulation. Branches are sequentially extracted from the queue of ready branches and fulfilled. If the queue of ready branches becomes empty, the barrier is reached. So the branches from waiting queue transferred to the branches of ready queues. We enter the next values of input variables as planned ones, and then send planned values to the current values. So we are ready to execute the next cycle. And that such a system operates branches to the end. So we propose methodology of constructing test system based on parallel language that consists of transforming the parallel algorithm to the TLM model. Then functioning reactive system is described as parallel language, and in the parallel we describe the system as a whole and debugging, and then we debug the integrated description of the system. Here is an example in that the considered simple example of manipulator. We add the description of the behavior of environment. So if we consider the system as a whole, we have 10 simple branches. In the first moment, we have 3, 1, 2, 3, and we have 2 vectors of variables. The first variables belong to an environment, and the 3 to the control algorithm. So here is a simple example of generating test patterns. Here are steps or cycles of simulation, branches, queues of ready for execution, queues of waiting, current values, and planned values of all variables. So the current values are stimuli in the test pattern, and planned values are results of simulation. So we can generate test sequences using simulating, debugging that algorithm. And we have only 2 outer variables when we simulating the system as a whole. That is the sensors, signal from sensors of the system. And all conclusion. A methodology for constructing a test system is proposed, which allows generating a test sequence in the process of debugging specification of reactive control system presented in parallel language. There is a software support of the methodology, simulation and debugging tools for parallel language, and synthesizers for parallel language in the hardware model in the Verilog and C languages. That's all. Thank you very much for your attention. Please, questions?
Thank you for the presentation. Unfortunately, it was too long, about 10 minutes more. So we don't have time for questions. And we directly switch to the next presentation, number 2, which is by Alexey Rozhanov, on some trends in updating the nomenclature of specialties of researchers in the areas of research methods and means of intellectualization. Yes, please.
Dear colleagues, good afternoon. It is a great privilege for me to participate in conference with all of you together. For familiarization, I propose a brief message on the theme Some Trends in Updating the Nomenclature of Specialties of Researchers in the Areas of Research Methods and Means of Intellectualization. Background of involvement in the problem and why, an invitation to participate in writing an article for the Great Russian Encyclopedia Artificial Intelligence in Russia. The possible interest in this topic is due to the problems of system integration. As part of the paper, we do not consider in general artificial intelligence domain. The focus is on intellectualization as a process with two or more control methods, including such individual functions can be naturally interpreted in the subject area of pattern recognition. It is necessary to take into account not only local problems to achieve qualitatively new results in the field of artificial and hybrid intelligence, but also requires to make their generalization in the context of popularization. In the subject area, we will focus our attention on two aspects. Greater transparency needed, guardrails essential, motives, greater transparency needed. Artificial and hybrid intelligence technologies are dramatically changing people's lives. Therefore, we should combine our efforts to increase the transparency of the processes of developing new technologies. Guardrails essential. We cannot afford to continue playing catch-up regarding AI, allowing its use with limited or no boundaries or oversight and dealing with the almost inevitable society consequences after the fact. No matter how we talk about the definitions of artificial intelligence, the legislator is ahead of us, so the following slides show the definitions of artificial intelligence and artificial intelligence technologies in accordance with one of the new existing laws, on the example of the legislation of the Russian Federation. So why do we give such examples? Along with the advanced legislative initiatives, other derived regulatory documents are also undergoing changes. In accordance with the topic of the report, the specialties of the relevant researchers within the new nomenclature are also classified as such. So, of course, the essence of the report is not lengthy arguments about the next definition of AI, taking into account the encouraging wording of the reviewers and with gratitude for their support, the emphasis on the predominance of popularization in the relevant intentions is outlined. A routine review of the updated content of the nomenclature of researcher specialties is published in the printed report. Therefore, goal orientation implies the key question: what do we objectively do not know about AI and do not relate to AI in the foreseeable future? Short-term and medium-term prospects are assumed in this case. Software implemented services of a high degree of automation, informatization, intellectualization, etc. already today have a significant impact on the processes of creation, production, and distribution of goods and services for economic and cultural purposes, and in the future this influence is more than likely to increase significantly. The following three slides present arguments on the problems of the technological gap in the field of AI and the conditions for capacity building. The interpretation of new technologies and the various integration components under the auspices of AI can already be presented at this stage not only as a multi-purpose technology, but also as a set of super large datasets organized in a very specific way and used for representation. Such practical results in the aggregate of accumulated information resources, relevant services and technologies have been, are and will continue to be increasingly used in both the economic and social spheres. More information about these and related materials can be found in the Profile Project and ResearchGate, Technological Gap in the Field of New Technologies and Futures of Intellectual Property Protection of Systems with Reliable Science of Artificial Intelligence in Russia. So, due to the dynamic development of the situation that has arisen, a significant number of problematic issues appear, although many of them are obviously outside the intellectual property (IP) policy and are related, for example, to such areas as labor policy, ethics, human rights, etc. So, in conclusion, a number of priority issues are proposed, slides 14 and 15. Responsibility for administrative decisions in the field of intellectual property, discussion points and the context of capacity building, see more details, final slide 16, application research directions of the scientific specialty 1.2.1, artificial intelligence and machine learning. Pre-finals clauses. The short-term perspective includes specialized accentuation, addresses the issue of cognitive semantics aspects that cannot be represented by traditional digital and logical means, discusses necessary conditions for purposeful and sustainable convergence of decision-making. One of the most interesting and rapidly implemented applications of artificial intelligence technologies is in the field of registration and protection of intellectual property rights. For interested researchers, indicative questions are given: responsibility for administrative decisions in the field of intellectual property (IP). What measures in the field of IP policy could be taken to help contain or reduce the technological gap in terms of AI capacity? What forms of cooperation between countries with a similar level of technology development in the field of AI and IP could be? Generalizing emphasis, discussion points and the context of capacity building is presented here. In particular, the application presents the research directions of the scientific specialty 1.2.1, artificial intelligence and machine learning. Draft passports of scientific specialties, nomenclature of scientific specialties unpublished. Printed version available, Higher Attestation Commission of the Russian Federation, access mode without restrictions. Thank you for your attention. Дякую за увагу. Dear colleagues, I do not speak English well. Please write your questions in the Zoom chat.
Спасибо.
Okay. So thank you very much for your presentation. Спасибо за доклад.
Да, спасибо большое.
Уважаемые коллеги, dear colleagues, do you have questions? I could translate them. No questions. So I can look into the chat. Nothing. Okay, so if nothing, then we would like to thank the presenter again, and we have 5 minutes back from the 10 used extra, so we just have 5 minutes lag according to the schedule in total. And according to the schedule, the next presentation is by me. So I'm here not a guest, and especially not a distinguished guest, but just one of the speakers, and also doing some advertising notes or work. Okay, so the next talk is by me on robustification of sequential statistical decision rules for stochastic data flows analysis. This is the joint work with my colleagues, and I now share my screen. Okay. So this is about the presentation. I will try to be quick. Well, the talk is about statistical decision rules, namely about sequential statistical decision rules, the aspects of their robustification, and those decision rules are applied for analysis of stochastic data flows. The work is with my former PhD student, Ton That Thu from University of Da Nang from Vietnam, and with my current two master students, Dai Yu Kun and Wang Yumin. Well, the contents is indicated here. So we considered 3 models of data flows, and we considered 2 problem settings in terms of simple hypothesis and in terms of composite hypothesis. Well, the sequential approach is a powerful tool for construction of statistical decision rules on parameters of stochastic data flows in many areas, especially in medicine, in quality control, in finance, and others. These sequential statistical decision rules are optimal for hypothetical models, but in practice, the data we observe in data flows are usually deviate from the preset hypothetical model. So the problem of performance characteristics analysis under distortion and the problem of robustification of sequential statistical decision rules is important. There are a number of attempts to attack this problem. There are 2 directions. The first one is simple models, shrinking neighborhoods, and a very limited number of papers in this direction. The other one is empirical robustification in the areas related to applications. In this talk, we try to solve this problem theoretically for more or less rich class of models. We start with the very simple model of the data flow with independent, identically distributed observations. On a probability space omega fp, taking values in a set U, which is discrete, with a probability distribution 1, where hypotheses are simple. It means that we exactly formulate which value takes the parameter. Not a set of values, but just one point. One point against another point. So the decision rule can be written in form of 2, where lambda n is the log likelihood ratio statistic. D equals 0 or 1 means that we stop the observation process and accept the corresponding hypothesis. D equals 2 means that the next observations need to be made because we don't have enough information to guarantee the requested accuracy in terms of error probabilities of type 1 and 2, alpha 0 and beta 0. Using them, we calculate the parameters of the decision rule or of the test, the parameters C- and C+ indicated in 3. Suppose that the hypothetical model is contaminated and the factual probability distribution bar pk is a mixture of the hypothetical version and of a contaminating distribution with an unknown probability of outlier presence. So for this situation, we propose a family of modified sequential tests 5 with 2 more parameters G- and G+, which are in fact the truncation parameter for the test statistic. To analyze robustness quantitatively, we introduce the following robustness characteristics: the risk functional as a weighted sum of error probabilities, the guaranteed upper risk functional, which is defined as a supremum of the values of the risk over all admissible distortions, and we define the test. Minimax criterion, it means the functional under constraint size, the expected number of observations. Okay, hope that I'm back again. So the situation was also extended to different types of distortions. For the distortions that can be formulated in L1 metric, also in L2 metric, and weighted C metric. So we don't go into details here, but the other model of data that was considered is inhomogeneous data following the model of time series with a parametric trend indicated here. The similar results are presented for that model also. So the characteristics of the tests are calculated under distortions, and the minimax robust sequential test or decision rule is constructed. The similar results also obtained for the data with dependencies, especially here we have results presented for Markov chain model. The hypotheses are formulated according to about the parameters of the observed Markov chain, about the vector of initial probabilities, and of about the matrix of the one-step transition probabilities. Suppose that this model is also contaminated. We propose to use a family of the tests with the test statistics lambda and g with 2 times n+1 parameters, And again, these parameters can be chosen to construct the minimax robust sequential tests. Theorem 4 gives impression how much deviate the characteristics of the test from the hypothetical versions. So here we have deviations of order 1 on the contamination level. In the numerical example, we compared the sequential probability ratio test with the constructed here minimax robust test. And the results you may see at figure 1. The black curve is for the classical test, the blue one is for the minimax robust test. Here you may see the dependency of half sum of two error probabilities on the contamination level. And in figure 2, we see what we pay for the gain in accuracy and robustness. Similar results were also obtained for the case of composite hypothesis setting. Well, I will not go into details here, but we'll just show you the main results. Theorem 6 gives asymptotic expansions for the expected sample size and the probability of hypothesis acceptance under condition that the parameter being fixed. Corollaries 1 and 2 give the expressions for error type 1 and 2 probabilities and also for the conditional and total expected sample size. Here you can see how does the error probability grows with the contamination increasing. The asymptotics of the characteristics for the sequential decision rules in this model are given in theorems 7 and 8 here. So error type 1 and 2 probabilities are analyzed in equations 14 and 15, and the expected sample sizes are given here. So again, for this model, following the same methodology, the robust sequential test was constructed. And how much do we get from it? We can discuss using these two figures. On figure 2, you may see the dependencies of error probability on the truncation level. So the bigger row is, the more essential truncation is, the more essential modification we do. For example, if we have contamination with the probability 0.05, then with rho equals to 0.8, we get almost 2 times gain in accuracy, and we pay for this. We pay for this in terms of the expected number of observation, just 1 extra observation, which is not bad. Well, I will not give much words for conclusion. I will just tell that the results are also applied for monitoring of medical data for the quickest sequential detection of the individual efficiency of used medication scheme for patients, and also in monitoring of the epidemiologic process in Belarus for typical scenario identification. I would like to thank all of you for attention. There are some references, and really we do have some time for questions, but not too much. Do you have questions? If yes, please. So no questions. Okay, if we don't have, then we go according to the schedule to the next position, which is presentation number 4, and it should be by Valerian Ivashchenko, Nikita Zotov, or Maxim Orlov, and will be on semantic logic of repeating events in a forward branching time model. Please.
Good afternoon. Do you see my screen? It's okay. I want to present my report about semantic loading of repeating events and a forward branching time model. I want to say, excuse me, perhaps, and excuse my slides, which have perhaps a non-formal style. But so begin. My report consists some parts, and I want to tell about the topic and approaches to solve it. Some tasks which connected with this topic, and our proposition, our models and algorithms. Semantic loading is an introspective mechanism capable to support process introspection. It is important because it is useful to achieve such goals as process mining and explanation of problem solving. Also, there are several aspects explored by approaches to semantic loading. I select such aspects as space-time model of processes, type of semantic log data structures, and specifics of the processes which to be logged. Time structures can be various, and this slide demonstrates a linear structure, forward branching tree, backward branching tree, and directed acyclic structure. The topic is concerning the linear and forward branching tree, and linear as subcase. From the point of view of data structures, we deal with partially persistent structures, fully persistent structures, and confluently persistent structures. And in this report, we are restricted with the fully persistent data structures. Informational and knowledge processing environment can have own specific, and there are environment without local or global stage storage, which can be accessed unbounded number of times, without global storage, but with a local storage which cannot store a global state of the environment, and with global storage, which can be accessed unbounded number of times and store global states of the environment. We concentrate on the second two cases. Our approach may be compared with the existing approaches, which you can find in published papers. Mainstream approach initially starts with the sequence of process events and try to determine the wide set of K types of events, and finally events are logged and specified depending in its type in the log structure. Our approach is opposite. Initially, we have a knowledge base capable to describe the events of the process. These events are reduced to basic types of events, and finally, we need to log these events. As for repeating events, these events naturally occurs in processes with a locally cyclic space-time structure. Our approach is use unified semantic knowledge representation. This representation model uses semantic networks and has ability to represent non-factor of knowledge, ability to represent events, phenomena, and processes. And all events in this model are reduced to actual or non-actual membership relations of the semantic code set model. For example, this slide contains examples of semantic networks which describe knowledge processing states as semantic network. Semantic log structure in our approach, it is also a semantic network which has hierarchic and network structure. This slide contains illustration. This structure consists of simple structures of links of semantic logs. This structure is built on the principle of triple free stack structure. It is similar to binomial heap, but there are some differences. This structure grows incrementally, and the structure preserves linear order of events. The implementation of our approach is oriented for the integration platform, which has client server architecture and has a multi-tier architecture for knowledge driving systems. Client server architecture consists of variety virtual machine and ontology virtual machine, which interact each other. The key semantic log tasks are event identification task, log construction task, log navigation tasks, and such tasks which can be called as problems: anteriority problem and last common event problem. In the acyclic structures, we have 4 cases of anteriority. It is antecedents when the first event precedes second. Consequence, it is opposite case. Coincidence when 2 events are identical, and alternativeness when events not precede each other, don't precede. And for example, in cyclic structures, we have 5 cases where each both events are dependent. Primary log event task, it is task to find the primary event in the log. Last common event task, it is to find corresponding events. For on this slide, it is showed with a green color. There are also basic navigation tasks. There is get event by log index number, to find event by identifier, and to get event identifier. In the case of repeating events, we deal with event repetitions, which also need to be identified, and we need to some additional navigation, solve additional navigation tasks for repeating events. For this slide illustrates 2 events which repeat this a long time, and we can ask the system to sequentially access of these repetitions. To solve this task, we propose a model which considers sets of events, identifiers, descriptor structures, log structures, natural numbers, and truth values. And also, this model contains functions which need to be evaluated to solve this task. These functions are showed in this slide. Also, several algorithms were developed and implemented. Our implementation was made using in the integration platform, and all developed algorithms have sublinear time complexity. Thank you for your attention. Perhaps some any questions?
Yes, thanks to the speaker for the presentation, for keeping the schedule. And we have time for one very short question, if any. So no questions appear. Also, the chat is empty. So we move to the next presentation. We're still 5 minutes behind the schedule. And the next presentation will be, I don't know for now, by Mikita Shuldal or by Alexander Vasilievich Tuzikov, maybe by Mikita. on development of molecular autoencoders as a generator of protein inhibitors. And this will be the application for prediction of potential drugs against coronavirus. Yes, please.
Can I share my screen, right? So is it all good? Is my screen visible?
Yes, it's fine, Nikita, please.
All right. Yeah, so good time of the day, everyone. So as it has been mentioned, the work that I'll be presenting is called the development of molecular autoencoders as generators of protein inhibitors and its application for prediction of potential drugs against SARS-CoV-2. So this is a sneak peek at our team. We're based in the United Institute of Informatics Problems and the Institute of Bioorganic Chemistry. And our main area of expertise is computer modeling of novel drugs. So without much further ado, let's jump into the pipeline of modeling drugs. So here is a rather general way of doing drug design. Usually, each disease is connected to some protein, which actually needs to be enhanced or silenced by a compound that we call drug. And in order to find the best compound candidate for the target protein, one should screen existing compound databases or generate new compounds and estimate compound fitness to the protein using a set of molecular docking methods. So what we did in our work is we actually developed a deep generative model, and we tried to incorporate it into the pipeline that's shown on the slide. So this way we're capable of enriching the compound sets at early stages of computer modeling. So the basic idea was to be able to, as I mentioned, enrich existing pipelines with the new potential inhibitors based on the ones that had already been identified in the screening procedure. So as is the case with this model, we're not restricted to database compounds only, which is a restriction for screening methods usually. And we also are capable of getting away a little bit from the bias of the so-called pharmacophore models that are built for the screening. So hence we had the following motivations for using generative models. First of all, a very well-known and common approach in drug design is actually similarity search, but it enables finding new compounds only, so to speak, around a set of selected compounds for similarity search, right? While our model actually allows for more thorough examination of the molecular space. And not only that, but it also enables us to quote unquote generate good generate compounds from good parts of the space. We can capitalize on pre-computed value of the free binding energy for the compounds used in the training model, and we can try to identify parts of the space where the good compounds, the good binders actually are. And finally, we can use other compounds, for example, from the test data set to generate new compounds from. So let's quickly touch upon the types of data that we fed to our model. So there are molecular fingerprints, which are a well-known type of a way of vectorizing molecular data, and they are used a lot in supervised problems or for the similarity search itself. However, they have one big flaw, which is actually that having a fingerprint, there is no easy way to restore the original compound. or compounds which the fingerprint belongs to. So this becomes especially crucial when dealing with compounds that might not be found in databases, or in case of generative models in particular. So in our work, we used the SMILES notation of chemical structures, or vectorized SMILES notation to be precise. And it had a lot of benefits that come with it. So first of all, SMILES representation is string representation, strictly speaking. So we can actually apply some common techniques from NLP, natural language processing, including the vectorization part, and also the use of LSTM networks that are, of course, very well fitted for the sequential data. And yeah, and of course, SMILES embodies both qualitative and quantitative aspects of the model. So moving forward, just to quickly give you an idea of the processing conducted, we had to reduce the SMILES dataset to that only containing drug-like atoms and compounds overall, also filtering out some SMILES based on the length distribution and other factors. We got rid of duplicates and molecules with huge molecular weight, and in the end, SMILES were vectorized in order to be able to be fed to the model itself. So actually, we developed two models. So the first one is sort of a vanilla autoencoder that uses a reconstruction error, and is basically aimed at being able to reconstruct the original, to reconstruct on the output the original vectorized SMILES it was given. So the second model is more interesting. It's actually a semi-supervised autoencoder model. So it has an additional neuron on the latent layer, and it's responsible for the ligand-protein interaction energy, which you usually call binding energy. And during the model's training, a predicted value of this free binding energy is passed to the neuron on the latent layer. So this, as you can notice, this neuron is not connected to the encoder part. It's only connected to the decoder part. So this is done so that the decoder, instead of trying to derive the binding energy or binding properties of the compounds from the embeddings, we'll simply get this value from the neuron. And actually in the generation turn, it will be able to reproduce various compounds with energy close to the one that was passed to the neuron, passed to the given energy. So what actually both of these models allow us to achieve is to create a molecular space on the latent layer, or so-called embedding space, or molecular embeddings to be precise for our case. So it's particularly useful and a very well-known concept in natural language processing. And we are doing a very similar thing here. So we create a space that various metrics can be introduced in, and compounds with similar properties are supposed to be close to each other in this space. But a very important thing is that we also project the properties of compounds in terms of the binding affinity to the molecular target to this space when considering a semi-supervised model. So it's important to note that we also trained an additional regression model to predict the binding energy values of generated inhibitors, generated compounds. And it was done to improve the capacity, to improve our capacity of promising compounds that we can actually then evaluate with the molecular docking. So this way we can generate thousands of compounds, then quickly predict their binding energies, and then set a compromising threshold so that we are able to pick up only those compounds which are feasible to dock in a chosen period of time. So later on, we end up having 4 metrics that we actually evaluated the results through. So the first one is, as I mentioned, the predicted energy. So we, of course, had to first of all evaluate our energy prediction model, and second of all, we used the model actually to filter out some generate compounds in order to dock only the ones that are more promising. So the second metric is actually a generated energy. So it only applies to the semi-supervised model, and is basically a preset threshold of energy that we wanted to generate new compounds with. The third metric is source compound energy. So this metric is connected to the type of generation, where we used other compounds to sample new compounds from. So we basically computed their embeddings, and then we added some noise to the embeddings themselves, and then tried to restore the new compound. And the fourth metric is actually our benchmark. So we evaluated the binding energy affinities at this point with docking, with molecular docking, in particular the Autodock Vina software. And it was our main judge, so to speak. So what do we actually have? So as I mentioned, we had 2 models, and we used 2 generation methods for both of the models. So the first method of generation was just generation from random numbers, which were drawn from normal distributions, where the parameters were derived using the taste data distribution on the latent layer, of course. And the second generation method was using source compounds, as I described previously. So if you look at the first model, the first row is a Bennings model. It's an unsupervised model, and we simply generated new compounds from random vectors passed to the latent layer. So despite the fact that this model doesn't take advantage of neither source compounds for generation nor any binding energy values, it's actually capable of generating new potential inhibitors of the chosen target by just merely generating compounds from the Bennings distribution inferred from the training data. So as you can see, we have more than 28% of the compounds generated with an energy lower than -8 kilocalories per mole, which is actually quite decent. And the best candidate from that set so far is -10.6 kilocalories per mole. So the second method utilizes, it's again an unsupervised model, but instead of generated from random compounds, from random vectors, I should say, we have compounds from the test set. We compute embeddings for them, and then we add some noise to those embeddings and try to restore the compounds. And obviously, they are different to the ones that were used as source compounds. So yeah, this method utilizes compounds available, and the share of generated compounds with high binding affinity is actually considerably larger to the first generation method, with 38% of compounds exhibiting the predicted values of binding energy less than -8 kilocalories per mole, and 4% showing the energies lower than -9 kilocalories per mole. Going to the semi-supervised model, the first generation method again is just generation from noise. However, at this point we have a neuron that's responsible for the energy, so we can pass different energy thresholds to that neuron. This model actually utilizes a version of style and content disentanglement, which is a common trick in computer vision, but for molecular data. So according to the results obtained, 31 and 64 of 31 and 64% of generated compounds show the value of binding energy with the deviations of 1 and 2 kilocalories per mole accordingly to the energy thresholds that had been set for that. And more than 27% of the compounds showed an energy of better than -8 kilocalories per mole, and 17.4% lower energies than the original threshold that was set. So the last model and last generation method, it's a combination of the semi-supervised model and the generation from the source compounds. So it actually proved to generate the top compounds throughout all 4 generation methods, and 52% of generated compounds are located within just 1 kilocalorie per mole deviation from the source compounds, while 16% of generated compounds has values of binding energy lower than -9 kilocalories per mole, and more than 40% lower than -8 kilocalories per mole. So let's look at some other statistics. So as mentioned, another machine learning model was implemented in order to predict the binding energy of generated compounds. And as you can see, we have a quite good correlation of this predicted energy and binding energy estimation by the docking procedure. So that's nice. If we look later on, so on the plot above, you can see it's model number generation method 4. You can see 3 distributions: the distribution of predicted energy, of energy estimated by docking, and the source compound energy. So actually, in this case, we generated new compounds from some source compounds. So as it seems in the beginning, we actually are doing a worse job in comparison to the source compounds, right? But since obviously errors accumulate on different steps of this long pipeline, it does not play to our advantage, meaning that the model is affected by the errors in the docking software prediction, and it usually is affected to the worse side of the error, not to the better side of the error. And it would be a miracle if we could generate compounds that are only better, but the results are still fascinating. If you look at the second plot, which is a distribution of difference of source compound energy minus generated compounds energy, you can see that though the average, the mean of the distribution lies around 1 point something, right? So on average, we generate compounds which are 1 point something kilocalories per mole worse. You can see there are a lot of compounds which are actually better. So if you look to the left of 0, you can see that there is quite a few compounds that actually possess an energy which is better than the preset threshold or the source compound energy. And even if this percentage is small, we can still benefit from it immensely. As we need to focus only on the best compounds, of course. We conducted a lot of experiments, including experimenting with various thresholds for the binding energy neuron on the latent layer. As it can be seen here, there is a lot to improve. However, there is a visible difference in the distribution for different thresholds, and lower thresholds produce distributions which possess lower energies overall on average. Another interesting observation can be found on this plot, where all wind energy, generation energy, and source compound energy are depicted. We can observe that with lower energies are of course better. We see less variance through the compounds that have been generated. So it actually reinforces the concept of generation from the certain parts of the molecular or embedding space, and clearly gets more challenging to generate better compounds. However, we can do it more precisely as the variance is lower, as you can see here. So I think this is it. Thank you for the attention and for your time.
Okay, thanks for an interesting presentation. Not too much time for questions, but the topic is quite interesting, so maybe there is one question.
May I ask someone?
Of course, yes, please.
So, my understanding is you are just using autoencoders to sort of compress the data, the original data, and then to generate from that. Once you get the decision, you train autoencoder, then you put some random numbers, say, and trying to some explore the space of your problem. Is correct?
Yeah, basically this is correct.
Okay. Okay. Then the question is, the question is, okay, you are using non-linear model. And then, by the way, that's secondary, but by the way, you are using T-SNE, just to convince yourself that the results are good. They are close in feature space, but it's also non-linear. So it's something like you're deforming your space to get the nice result, nothing else. Just some sort of lying to yourself. It's non-linear model. Okay, then what about the idea you're just using the same, but instead of this autoencoder, you're using linear method like PCA. Okay, you get your data, you convert them to principal component, you take the major ones, which are much smaller, and then you always have the way to convert that small to original one. So by definition of the principal component analysis, any component, say original variable, could be reconstructed from principal components with very small error. Can you comment on that, please?
Yeah, I can. First of all, there was a little bit of misunderstanding, as we didn't use TSNE. It was just an example.
Okay, that's secondary. Don't worry.
Yeah, so there's a lot of things to explore, of course. We did not really, as of now, put a lot of effort into exploring the latent space and actually whether or how well it's capable of compressing the molecular space. So the main incentive was to just be able to use this semi-supervised model. It's actually the one that we ended up using. And being able to do conditional sampling. So not only we want to generate from random numbers, we want to say we want to set an energy threshold, let's say -8 kilocalories per mole, and then only then pass random numbers as well as use other source compounds in order to generate compounds with a preset property of good binding energies. So there's actually a lot of work to do with the exploration of the latent space. But yeah, the main incentive was just to be able to capitalize on the data. So we have a lot of data, molecular data with already estimated binding energies. And we want our model to look at the data and try to generate new compounds, which are actually better than the data that we have, or at least as good as the best compounds in the data that we have are.
Okay. So actually by brute force, we can produce all the possible combination, and that looks realistic. well, it doesn't matter, it's very huge. But if you have a mechanism to select from all the combination, the best ones, then you have done. This is the problem, because all the optimization models, they're designed just to overcome this. So that any problem, yeah, have a solution by brute force, but the problem is we're never able to do that for reasonably high dimensions. Anyway, that's the question for next discussion. Sorry.
Yes, Vasily, I would like to a couple of words to say that the results of this paper much deeper than you speak now. So the results consider first important contribution of representing chemical compounds by small description. It's not obvious way, because it's not only represent by small description chemical compounds, but also reconstruct chemical compounds by this description. It's a very important and very complicated problem. And the second one, this is all this done for generating chemical compounds with some energy of binding energy, and this semi-supervised approach allows to do it with some threshold of this binding energy. It's also important stuff. And the third one, all these best compounds are going through the procedure of molecular modeling, just to find and to prove that they are really good for further drug design. So it's a very complicated problem, and not only just simple what you.
Of course, I do understand, but
yeah.
Nevertheless, there could be some more questions. Minimal energy, okay, there could be just two local minima. You just got one, and you will never go to the second one. Okay, I don't understand deeply the problem as such, so I'm a little bit naive on that, but just the question to clarify the point. Thank you very much. Anyway, it's an excellent presentation.
Yeah, the presentation is nice, and we have a lot for potential discussion. But we need probably to go according to the schedule.
Absolutely, absolutely.
Okay, so thanks for interesting question, and thanks for interesting discussion. And we go to the last presentation at this session, which is presentation number 6, and should be done by Tatiana Kim, as I understand, and will be on development of an adaptive motion controller for a two-wheeled mobile robot along a color contrast line based on the use of RL technology. So yes, please.
Good afternoon. Can you see my screen?
Yes.
Good afternoon, dear colleagues. Let me introduce myself. My name is Tatiana Kim, and I'm PhD student of United Institute of Informatics Problems in Minsk. Today, I would like to present article development of an adaptive motion control for a two-wheel mobile robot along a color contrast line based on reinforcement learning technology. Written by me and my scientific director, candidate of engineering science, Grigory Prokopovich. So what's the topic of the research? The purpose of the research is a development process of an adaptive motion controller for a two-wheels mobile robot along a contrast line. The controller learning process took place on the basis of the mobile robot using reinforcement learning technology. I just use RL, and it was implemented in MATLAB Simulink. For learning algorithm, we choose TD3 method. Then we created a reward function to minimize the distance between the center of the robot and angle of the robot position and tangents to the current section of the contrast line. The object of the research is the robot training mobile robot with a different drive, which is supposed to move along the color contrast line. The control system, it's a classic servo drive, including 3 color sensor and a speed controller that controls the angular speed of the wheels. Previously, we have experience and were carried out of the automatic tuning of the specified speed controller using the software model MATLAB called automatic tune bit, and then the application of genetic algorithm. Some words about bit controller. Sometimes with selection of the coefficients, it's a rather long process which doesn't always lead to success, since there are a chance of overshoot. In closed loop control systems, the controller use status observation to improve performance and correct random noise and errors. This concept is easy to put into words, but it will be difficult to implement, since the model can be highly non-linear or have large space of states and actions. There is also a problem related to the fact that for each line trace, it's required to find the corresponding bit value. And this problem can be quickly solved by using RL, reinforcement learning. It is one of the machine learning methods for solving control problem in complex technical system that can't or can be problematically described in an analytical form. In RL, the object of research is studied, as a result of which an artificial neural network in general that can be simulate the desired object. In table 1, we can see several types of actor-critic learning algorithms. Actor-critics agents use either stochastic actor or deterministic actor with a value critic or a q-value critic. We have chosen the TD3 method, which contains a deterministic actor and a q-value critic. On the next slide, I will explain why we choose it. Before starting the learning process, it's required to create a virtual environment for a function of a mobile robot and interface for interacting with it. Next, we should configure the agent model from the library from MATLAB. To implement the agent, the TD3 algorithm was chosen, which is characteristic by the fact that in addition to the agent, which offers specified action of the actor on session indication of the sensory system. Then 10 new entity are to use 2 critics that form a long-term reward. Next, we Next, agent is configured and format. The final stage is training and verification of the result of the training agent. The important state in RL is created a reward function as affect the performance and the agents, its relation to goal and the mobile robot seek to achieve. On the slide, you can see two criteria. It's taken into account as a reward for communicate action. The first, the distance R, from the center of the robot XY to the nearest unvisited point X0 and Y0 of the ellipse located of the line is calculated using the formula for calculating for distance between 2 points. It's formula 1. The closer the agent, the more reward it will receive. The further, the less reward. The second calculates the angle phi between the tangents to the ellipse at the point x0 and y0, where the robot should be. And the robot guide using formula 2. Since our reward signals consist is two signals and combined into one scalar. Then we determine that the distance between the line and the robot of the paramount importance as the resulting angle phi. We reduce in influence to get reward. The next stage is agent implementation. Implementation of the environment. There we need 2 points. It's first of all position of the robot and indication from the sensor. Then we need create agent implementation. In this process of training, the agent use the following data. The reading of the sensor in the middle of the line. This consists 3-line sensor. The distance for sensor of mobile robot, the center of the robot. Contrast line, as well as the angle between the normal and nearest section of the line and the direction movement the mobile robot itself. The next stage is stop criteria. It's used to reduce learning time. Each episode of the learning process can stop if the first, the simulation exists as a time allotted for movement along full ellipse, and the second, the robot has existed the distance to the center of the ellipse line. During each episode, the agent chosen an action. After the end, he updates his parameters based on actions and receives the maximum reward. In this picture, the main block is RL agent, where consists deterministic actor, which took state, and q-value critics, which took state and some actions every epoch. Then agent use algorithm learning. Okay, for learning algorithm took 2 hours 15 minutes. Then the results obtain the significance and comparison this with the previous work. In this table, comparing the result obtained earlier by the GA method with a new result obtained by the reinforcement learning method, we can conclude that the latter method reduced the number of episodes and training time by several times. According of our observation, the robot with the new coefficients move more evenly that with the genetic algorithm, there are no interrupt and bonds. In this graph shows that the highest reward, it's a blue line, it's more 1,100, and the average reward is more 700 units. Where the robot can be drive an elliptical curve in 1 second, minimizing the distance to the curve. In conclusion, we using the reinforcement learning algorithm, the optimal value of the bit controller for this robot were selected. We created a virtual environment for observing the robot. Learning was implemented using the TD3 method, using deterministic actor and q-value critic. Then, as a result, the tuned bit controller allowed the mobile robot to accurately move along the curved contrast line at a speed of 0.66 meters per second. I think it's everything that I need to show and speak. I will be glad to answer any question. Thank you for attention.
Okay, thank you for a nice presentation. And are there maybe one short question, just very short? So no questions. So in this case, I would like to thank to all the speakers, and I hope that every participant supports me in this. And so my personal opinion is the session was successful. So we have 100% of presentations planned, and the spectrum of presentations was really wide. The results for me were quite interesting, and the only thing I would like to say is some words of apology for the chairman of the next session because of a small delay with realizing this schedule with this session. So thanks to everybody for participation and all the best. Bye.
Thank you, dear chairman. Yes, so it was very intensive session, and so I was also satisfied with this. Well, actually, so yes, we need to avoid our break because we need to be in schedule. And now, just after a small tearing, in 40 seconds, we'll come back for the next session. So jump to your coffee and come back in 40 seconds. So, hello. I'm inviting you to back to our studio, and now our chairman of this session is coming to be with us. Please, yes, you can come here. Okay. So it will be the last session. So just only three presentations we'll have, and now I will give a floor to the chairman of the session, Dr. Viktor Skakun. So, yes.
It's a big pleasure to participate in this right now famous conference. This is the top level conference, and I would like to launch the session B4. It's a good idea to have the program at me. So the next speaker is Valery Malyshev, nuclear detection based on single point labels.
Hello, everyone.
Presentation.
Give me a second to start my sharing screen. Great. So my name is Valery. I'm the member of Medical Imaging Lab of the United Institute of Informatic Problems. And we developed an algorithm for nuclear detection using more easy to produce single point labels for host light images. So let's start with some general discussion. We have hematoxylin and eosine images where nuclear detection often is used for classification of different types of cells that can show some malignancy in tissue. And another part of our work is immunohistochemistry, where we analyze host light images colored with specific antibody to produce a reaction in tumor cells. So cell detection here is required to identify positively and negatively reacted cells. So for our research, we have used several data sets which are publicly available, and nuclear detection often is evaluated using these data sets. Here are 4 data sets based on nuclear segmentation, and 1 which involves classification. The last one, concept data set. So for evaluation, we have tried 5-fold cross-validation to ensure stability of our results, plus fixed train test split, which was involved in these data sets where they have it. So a small review. We have classical object detection, which works with object proposals. It includes such neural networks as masker CNN, RCNN, single shot detectors, and so on. And we have nuclear detection specific neural networks, such as HARNet, which is now state-of-the-art model developed in 2018. They're usually more complicated than classical object detection, but works much better. I think 10–15% of results, if I recall correctly. So if we remember about neural network object proposals, they usually predict rectangle using 1 corner and height and weight. However, there are some different ways to do that in recent research, such as extreme point heat map. When we create a heat map with points in corners of objects and then create rectangles based on this heat map. Or more simple center heat map, where we want to predict centers of objects and then create rectangles using those. So what's our idea? Considering often host light image annotation for nuclear detection is performed to use it by manually segmenting every cell, and we didn't have such resources for our immunohistochemistry part, we decided to ask our partners, histopathologists, to annotate them with single points, which helps to make more data for neural networks. There were some other works which did that, but then they decided to go with some automated segmentation and predict those automatically produced segmentation. When we think that it's not eligible because we better use original data and predict the original data. And if we think what usually histopathologists require, they want some aggregated data and ability to check if it is correct. So the segmentation usually is not required by partners. More important is, for example, counting cells or percentage of cells of different classes. So our idea is to predict heat maps of nuclei centers rather than segmenting them as in classical object detection or some methods of nuclei detection. So here is overly simplified idea. We have cell, we create a smooth point and then trying to predict it. So as for our deep learning model, we were motivated by HARNet. So we used UNet-shaped neural network with residual blocks to make better propagation of signal to the end features, and then dense blocks to interpolate for heat map. Also, we have tried several losses, but MSE loss we found out that works the best. Also, there were problems with our metric calculation to compare with other work, because other work are done with object detection, so with masks, so that every nuclei is segmented. So we couldn't use general metrics for nuclei detection and object detection, such as mean intersection over union or panoptic quality. So we decided to go with detection scores for true false positives. And the main metric for us was F1 score. So here you can see the result of prediction. We've predicted the heat map of centers of nuclei and then apply a watershed algorithm to produce round shapes and make some distinction between near-located nuclei. And then if we want to produce annotation for histopathologist, we just find center of mass of every nuclei and show it to our partners. So our results on testing with HARNet, because we used some recent advances in AI, such as new optimizer, ADMP, and new activation function, we could achieve better results using HARNet itself. And then we compared it to our own model with most of training parameters locked, except for the model and output data, because they predict different things. So as you can see, the results are pretty similar. They are plus minus 2%, which can be considered normal for deep learning algorithms to differ in such a way. So it can say that we can predict, we can make same prediction despite segmentation. Using our algorithm, using less data, which is of course faster to produce, and we all know that data is essential for deep learning techniques, and we still can get same performance. So some examples of how it looks like. We tried to add tumor segmentation to our model, and you can see the combined of different tiles, combination of different tiles. Here how looks tile predictions for immunohistochemistry. Most of cells are just found. Also, model works quite well to separate closely located nuclei. And then we find center of mass of every shape and combine it into AND format for histopathology software, and we can show it to doctors so they can make better diagnostic decisions. And so, thank you for your attention.
Thank you for your nice presentation. Questions? I see no questions. Please ask questions. So if not, I have one question. As far as I know, the histology images has a very high diversity, Did you try to apply your approach for different kind of histology images?
That's a great question. You're right. Okay. As I showed, there were some 5 data sets, plus we tried our model on immunohistochemistry. Give me a second. These data sets worked with were created based on different tissues. There were 2 with breast cancer. We had immunohistochemistry with breast cancer. I think, if I remember right, concept data set was prostate cancer. And one of the data sets had combination of different tissues. So I think I can say that we've tried different tissues and different types of histological images.
Okay, so it works.
Yeah.
It works. 2 more questions? So I see no question. So next speaker is Suisilun and Victor Skakun. Comparison of deep learning pre-processing algorithms of nuclear segmentation on fluorescence immunohistology images of cancer cells. Please upload your presentation and start.
Okay. Can you hear me clearly and see my sharing window?
Yes.
Okay.
Please make it on the full screen. Yes, okay.
Okay. Let's begin. Good afternoon, everyone. I'm glad to join in the conference and show you the presentation of our research. Our theme is about comparison of deep learning pre-processing algorithm of nuclei segmentation on fluorescence immunohistology images of cancer cells. Our significance of our research is that, firstly, it can raise accuracy of nuclei segmentation of fluorescence images of cancer tissue slices, and then, secondly, review the positive impact of pre-processing on segmentation. And the last one, we have compared the effectiveness of different image splitting and normalization method, and then you have to choose the best one. And our research object is showed on the right side. On right side is in fluorescence images, and it's about breast tumor tissue sizes, and it's stored in RGB color system. Channel red is cancer cell nucleus, and the channel green and cytoplasm of cancer cells, and the channel blue are cell nuclei. And on the bottom, it shows images in 3 channels, RGB and the masks. And on the left, it shows the area. It shows the area, histogram of area of nuclear size. We found that nuclei has the average radius in our research about 20 pixels. And then it's a pity that there are several disadvantages of the research object. Firstly, for cancer pathology analysis, our sample size are usually smaller, and it has high diversity of cancer cases, so not allowed to obtain a large number of historical images with high content quality. And secondly, experts and specialists need to manually label these images. It is a hard work for them to do. But fortunately for us, our original images, each image has hundreds of cells, so it is easy for us to splitting our image into smaller patches. So it is easier for us to increase the training set. And the last one, we all know that overtraining leads to overfitting. So increasing the training set through simply extracting with more and more overlapping will cause overfitting. And then there are two goals of our study, general goal and specific goal. The general goal obviously is to segment nucleus on the fluorescence images of cancer tissue slices. We used the UNITE structure for our research. And the specific goal of our study is to find the best way of pre-processing for our images. We separated our research into 3 steps. Firstly, define a training set of enough size. We only have 9 labeled images. So we choose 7 images for training, 1 for validation and 1 for testing. And then we tried 5 methods for extracting patches. And then 4 methods for normalization. And we have selected the neural network model, UNITE. It is well known that UNITE architecture is specially developed for biomedical image segmentation in 2015. UNITE and its variants presently are widely used in the field of medical image segmentation. On the bottom, it's the libraries and the tools we have used to build the structure of UNITE, and on the right side, it is a detailed structure for our detailed structure for UNITE we have used. It has a little modification on original one. So then, of course, there are many deep neural models at the same time with UNITE, such as USDNet, fully conventional net, SegNet, EdenseNet. No, but compared the results of these networks for image segmentation, we believe that UNITE is more sensitive to biomedical image, especially for segmentation. So we chose UNITE for our research. And we have tried 5 methods of patching extraction. It's the first step for our research. It is to obtain a sufficiently large training set and meanwhile avoid overfitting. We have tried these cases. Simply split into patches with overlapping, and split into bigger patches with overlapping or random cropping. And the last one split into much bigger patches. And on the bottom is the result after segmentation with using method of patching extraction. We can see in the table that the 4th method obtains the better performance. It's a better result. So we chose the fourth method for the following research. Of course, we can also see the fifth method in the table, that it shows the even better result in our research. But for instance, for instance 5, although it achieves the maximum number of pixels, we in the past did an experiment based on example 2, simply increasing the training site by almost 2 times. The obtained LU metric is slightly worse. That means simply increase the training site by overlapping, by more and more overlapping is not realistic. So we chose the first method for our following research. The performance curves on the right side, we can see that it has the better performance for the fourth method, and we did a visual inspection on the segmented results. It shows on the bottom, when sufficient patches are extracted to obtain complete coverage on the image, random cropping method is more powerful. On the basis of first step, we have done second step for normalization in our research. Purpose of normalization is to limit the process data to a certain range, eliminate the negative effect that caused by singular sample data in order to improve the quality of our input data. We have tried 4 methods for our research in our research. Without normalization, deviation by maximum value, standardization, and the last one is the most useful one, histogram equalization with subsequent deviation to the maximum. Histogram equalization is to enhance the image contrast by stretching the range of pixel intensity distribution. So we chose the last one as the best one. As it shows on the right side, we can see in the graphic that the image histogram equalization, it shows better performance in the results. And in the table, we can see equalization. It got the best performance in the table, but compared with the others, it not show the obvious difference. So we thought that the image normalization doesn't play a key role in our research. So although we chose histogram equalization as the best one, but it not shows the best performance. As a result, the predicted segmentation result is relatively close to the ground truth after using patchy extraction and normalization, especially at the boundary. We can see in the first group of images, image, ground truth, and predict mask. We can see on the boundary, it shows nearly nearly completely same. But unfortunately, in third group and in fourth group images, it has artifacts, and yes, it has image distortion on the boundary. So maybe in the future, in the following research, we have to add some post-processing step. So for the adherent cell nuclei, obviously, at the end, we can conclude that firstly, the random extraction of batches is more powerful, more useful. It's the best method for us to create the training set with sufficient size. And secondly, normalization can't prove that it has the active effects. That means it has no obvious effect in our research. Thirdly, through the comprehensive application of extracting patches, normalization, CPU augmentation, and using a neural network model, we have got satisfied segmentation result. And meanwhile, we have avoided overfitting. That's all. Thank you all, and thank you for attention. And is there any questions?
Thank you for your presentation. Please, questions. I see no questions. No questions. So I have one question. You used the already traditional UNet model for the segmentation. Did you try your algorithm? Did you try not algorithm, but did you try the same preprocessing methods using another neural network models like UNet++ or something like that? So did you try?
Yes, I have tried several models, tried several methods. So, but we have found that the UNet, the original, also especially the original UNet structure, has obtained the best result for segmentation. The other structure of models, such as LeSNet and DenseNet, the obtained result is a little worse than UNet.
Okay, thank you. And more question?
Well, I would like to ask one question. So to continue to the question what was asked just now, you said that, so in the presentation there is a, that in the quite first slides, you said about that you tried to compare it with the supervised standard, well, ordinary segmentation algorithms. So, okay, well, it is good that you combine this pre-processing and together with neural networks, but actually, so the task you're solving is also solving by standard proprietary methods, pixel or area methods. Have you just compared these methods and the results obtained by these methods with your combination standard plus neural network? Because there are unsupervised methods which actually solving this task probably not so good, but that is a question. Have you compared?
I have compared complex network. For example, UIIP has only one process as encoder, so we have built the complex structure for UIIP half using UIIP and Durgoi using SegNet. And the complex structure for neural net is not shows the obviously optimization in our research. So we thought unit, the original structure unit is more useful for us in our research.
Okay, thank you.
So, okay, thank you for your presentation. The next speaker is Alexander Leinikov, Alexander Nedvedь, Alexey Белоцерковский, and Stanislav Sholtanik. Sorry. Multiple humans pose detection algorithms for real-time video.
Yes, hello guys, I'm here. Do you hear me?
Yes, yes, okay.
Okay, so starting to share the screen. Okay, hello, nice to meet you. I'm grateful for the opportunity to participate in this conference. So I'll be presenting you a multi-personal detection algorithm. Wait a bit, I will hide the Zoom. Okay. So basically this algorithm, okay, let's just walk through the solutions that we have in the like current solutions, right? So basically the problem actually is to understand the human position, right? And this is a pretty old problem that was solved like years ago. And one of the classic solutions for that is like basically there are three solutions. First one is 2D solution to detect a person's, a human's pose using a predefined human model. The second one is the same one, but without a predefined model. And third one is the 3D approach that uses several sources, like several cameras, to be able to understand the spatial model of the person, right? But all of them are pretty old, and the level they works is not sufficient for us. So basically, the classic mathematical methods that I used in this type of tasks are classifications using decision functions, distance functions, also clustering algorithms. Also, like nowadays, all of these kind of problems are solved by neural networks. So we're going to be focusing more on neural networks and on our approach. So basically here you can see just my friends, yeah. I was testing the algorithm on them. So as you see, we decided to go a bit further and to add some more limitations to the problem. Because we don't want to detect only one person. We would like to find a way to detect basically unlimited amount of persons, right? Of people. And we still want the algorithm to work stable, because actually when you increase the number of people, it should probably work bad. And that was the main goal for us. So as we dive deep into the problem, so basically there are three main problems with building the human virtual skeleton. So the first problem is that each image can contain the unknown number of people. And basically they can appear or disappear and at any position and any point of time. And as we do the process in real time, so basically imagine you have like, for example, 30 frames per second, and you analyze almost each frame, and each frame can, like, the amount of people can change like every second. and basically they can move and interact with each other. And so we go to the second problem, that basically the interactions between people, because interactions can cause different complex spatial interferences, collisions. People can contact each other, and basically from the side of computer vision. So, for example, when someone touches with his hands someone's shoulder, we have to understand that there is a shoulder and there is a head, someone's head. So we have to separate these parts. And the third problem is the basically, as I said, the complexity of execution increases with the number of people. And it was basically a great restriction for the real time, as I said. So we have like a lot of frames, a lot of interactions between people, they move, and basically the amount of people can increase. Okay, so how did we solve that? The algorithm, basically the algorithm is a bottom-up method. So we estimate associations between parts, basically body parts. That means like arm, for example, leg, chest, and so on. And also we estimate the two-dimensional vector fields, which help us to encode the location of each body part. Actually, the location of each joint. Joint is, as you know, is like a moving part of the body, right? So basically, our algorithm has three main stages. Let me demonstrate them. So first of all, the first stage is preprocessing stage. We generate, like using a neural network, we generate the characteristic maps to filter areas and to narrow down the search. Because we don't want to analyze too much information, because that would be pretty slow. So then we separate to, so there are two algorithms working in parallel, because first of all, we have to detect body parts, and then we have to detect joints. And only after having body parts and joints together, we can try to merge them. And then we can try to understand which joint and which body part is like belongs to what person, right? Because like, as we know, each person has like 2 hands, 2 legs, 1 chest, and 1 head, right? So that would be a third step, is to handle multiple people. Basically, we have a huge set of body parts, and now we have to join them in a person's body, right? And make that for every person on the picture. And the final step is to build a virtual skeleton. So basically to map all the data we have on the picture, and make sure that like all the locations are positioned on their anatomical body, basically body parts, right? So basically make sure that they match. So let's walk through all these stages. So first stage is image processing, and the first stage is basically a convolution neural network with we use the first 10 layers from the VGG19 network, and basically we generate what we do. What is the output is the characteristic maps. As I said, just to filter areas of interest. And after that, after filtering, we finish post-processing, and we send these maps to our second step, which is paralleled and divided on 2 branches. Yeah, so as you see here, there is a like kind of interactive flow of the algorithm. So the first image is just an input, just an RGB image. Then the two next images are these parallel branches. So first branch of the neural network detects joins, basically detects the maximum points. As you see, they are red. And the second part, parallel part, is detecting basically the body parts. And then we join them together, and we are able to basically position the body part on the image. And then the next step is to understand, it is the first image, it is to understand like what part belongs to who, right? And after finishing this step, we are able to build the virtual skeleton. So let's walk through these parallel algorithms that are used to predict body parts. So first one is the simultaneous body parts detection and association. Sorry. So basically, the convolutional neural network predicts a set of probability maps, and so it is the first output of it. And the second output is a set of two-dimensional compatibility vector fields, which store the degree of compatibility between leaps. What does it mean, and how it helps us to understand? Basically, the output of this layer is the compatibility between limbs. So basically, we understand which limbs can join between each other. And we, for example, having this information, we won't join the leg with your arm, for example. Yeah, we know that the arm is joined only with the shoulder, and like that can help us basically. And okay, so the next step is to understand these body parts, right? So to build probability maps to detect body parts. So basically what we do is we try to detect these joins, right? And our main problem is to find the peak point. So basically the most hottest point on the joint. So for example, if there is a one person on the image, so there is only one peak that should be presented for each probability map, right? Because as you see here, so for example, the green one on the picture, the green circle is basically a probability map. And to be able to locate a concrete coordinate, we just detect a peak. And sometimes it could be a center, sometimes it could be it could lay somewhere else, but like 90% of the time, basically it is a center of the probability map circle. So, and the problem is if there is more than one person, so the peak can be corresponding to like different visible parts. And that was also a difficult issue to solve. So, okay, so how do we calculate? So one of the data that we use is we use a vector field. And how do we calculate the vector field? So basically, yeah, so one of the possible ways to understand that one join, for example, the blue point, right? How can we know that the blue point and the red point are connected, right? So basically, we add one more a middle point P, and it is a vector. So we try to understand if it lays on the in the area of the body part in the image. If it does, then we understand the direction of your body part, and we understand that blue point can match the red point, and that is done like for every body part. Next, after having all the body parts together, we have to separate them, and we have to understand which ones, which person owns which body part, right? So basically, to solve this this problem, we use graphs. Because basically it is the most convenient approach for that, because we have vectors, we know the direction, we know that every person can have only, for example, one type of body part. So using graphs, we are able to basically to separate them. And as you see on the picture 3, knowing the direction, we just know that each point, like each chest, belongs to each person, and there is no way to join them somehow else. So as for basically this was an example of processing basically one person, right? And the next issue is to process the n amount of people on the image, and we solve this problem using affine fields. So basically, when the task comes to be analyzed in a multiple amount of people, so it becomes an NP-hard task, and like with a lot of relaxations actually. So to be able to increase the efficiency, that means that we wanted to make it faster and basically to consume less execution energy. So we had to add a few optimizations. So the first optimization was to minimize the number of edges that were chosen to obtain the skeleton. So basically that was a filtering that I said before. And the second optimization was to, so basically the matching problem is decomposed into a set of bidirectional subtasks. Yeah, pretty difficult language, but basically this optimization means that knowing the direction of each body part and each joint, we are able to solve the issue faster, because without direction it is a very, very slow solution. Yeah, so one more example of how the graph works for multiple people, multiple persons detection. So basically, first image demonstrates just the graph we have. We know that one skeleton can contain, for example, only one red, only one green, and only one blue person, right? So then we pair them. So basically, we pair all the red points together. We pair all the green and blue points together, and basically these points are the joints of the body part. So basically, every body part, for example, let's check the body part between the green and blue points, right? So basically, there are two body parts, green blue and blue red, and both of them share the blue point. So basically, in this case, we can separate the graph into two graphs, and as it is an interactive process, so by separating them step by step, we can finally get so the output would be the separate parts. I think that's it. Thank you for the attention. Any questions?
Thank you for your presentation. Please, questions? So I see right now no questions. So I have one question. So you're climbing for real-time video.
Yeah.
The real-time depends on hardware. I think what kind of hardware, what kind of requirements do you have to apply for the hardware to create a real-time video for such complex processing?
Yeah, basically, we've started working on this algorithm in like I think 2 years ago, and basically the start was the AI hackathon here in Minsk, and as I had an experience in iOS development, so we decided to bring in some more limitations because we do not want to run them on servers, run the algorithm on servers or on some powerful machines. So our main limitation was to run the algorithm on board of mobile device. So basically we were testing the algorithm on 2 devices. These are iPhone 6, a pretty old device, and basically it worked pretty slow because of the hardware. But when we were started to test the iPhone X, which is pretty I don't know, like popular device with a good GPU and CPU, the results were so basically the results were the algorithm was working 22 FPS frames per second, and the storage, it weighted about 28 megabytes. So that was pretty so basically this was aimed due to the optimizations that we did, because previously on our first stages the algorithm was like 200 megabytes, and we were able to decrease the size almost in 10 times.
Yes, sounds promising. Yeah, thank you. More questions? We have no questions. This was the last presentation of this day. And right now I would like to announce one more conference. This conference will be held in Minsk at Faculty Radiophysics and Computer Technologies next year and end of April. End of April next year. The name Computer Technologies and Data Processing. So please, I cordially invite you to participate in our conference. So thank you for your attention.
Okay, thank you, the chairman. So I would like to thank you, colleague, for this nice moderation, as well as for the invitation to the conference. I think it should be spread to all the networks and to our email list and in our organizations. And by the way, do not forget to post whatever you like about the conference using hashtag in Facebook, at least hashtag PRIP, hashtag PRIP'2021, hashtag PRIP'2021 online. And well, thank you, speakers, for this nice session. What I'd like to say that we have very intensive days, so we not getting lower in our speed. So and I think tomorrow, I'm trying to announce what we'll have tomorrow. Tomorrow we'll have a panel discussion. I think it will be hot and very provocative, because we'll have colleagues from different countries and from different specialities, let's say. So scientists and non-scientists, as today speaker, invited speaker said that he's not scientist from Croatia, but still he has a special opinion about AI and legacy legislation and educational problems. So the panel will start on 10 a.m. Minsk time zone, and then after the break we'll have our scientific sessions and the closing, of course. So there is everything what I'd like to say for today. Now, just enjoy your evening and see you tomorrow. Thank you. Bye-bye.
Artificial intelligence. We objectively assess the importance of this topic. However, there is still no consensus on whether all tasks can be solved using these technologies. Abuse or obligatory use, we will raise such issues of ethics, modern information society, and cybernetics. This is the story of our virtual conference on pattern recognition and information processing in 2021, which has already begun. Here, right now.